Greetings everyone. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. Ladies and gentlemen, today I want to take you through mathematics paper 1. And on this mathematics paper 1, actually, I wanted to address some of the tips. I wanted to explain some of the tips that will enable you to score maths paper 1 exam with higher marks, or actually to get an A+ in mathematics paper 1. Right, ladies and gentlemen, here it's my YouTube channel ID. Kindly don't forget to go through it, like, subscribe, and hit the bell button for future video notification. Right, without wasting time, let's now go through the slides. Right, a wise man once said, in order to change your life, you have to change yourself. And in changing yourself, you have to change your mindset. So this is very, very, very important, that you need to actually do not doubt yourself when you are doing things. You need to work hard. Then working hard will result in good things. Right. So now, when you are given, like particularly in maths paper 1, ladies and gentlemen, I want to give you tips on how to get good marks in mathematics paper 1 final exam. Number 1, we know in mathematics paper 1, we have the following topics. Number 1, in maths paper 1, we have what you call algebra. Algebra, it's a paper 1 topic. Secondly, we have sequence and series, followed by functions and graphs. Here I used 2 asterisks to indicate to you that this is one of the topics that has a lot of marks. So we'll talk about this. Then thirdly, I'm going to say on number 4, we have what we call the functions. I'm going to say it's functions and graphs. After functions and graph, we have financial mathematics. Then after financial mathematics, we'll talk about differential calculus. Even this one, it is one of the topics that has a lot of marks. Then number 6, we have probability and the fundamental counting principle. Right, under probability and fundamental principle, these are the least topic. These are the last topic that have few marks. They do not have more weight in terms of the marking, but in terms of marks, I mean to say, but it does not mean that you must not go through them. You need to go through these topics. So I would suggest that when you are practicing, let these 2 topics be the last topics that you need to focus on in order to get an A+. So now, without wasting time, I want to take you through each topic that I just explained here. I will first start with algebra. Let me start with algebra, ladies and gentlemen. Right, under algebra, ladies and gentlemen, I want to tell you something good about algebra. Ladies and gentlemen, algebra is one of the easiest topic in maths paper 1, but most of the learners, they take it for granted. I want to address something. I want to tell you something important about algebra. It's been a while teaching mathematics. A learner or a student who's good in algebra is good in maths, because most of the questions that arise in the other chapters, they actually comes from algebra. For example, manipulation of variables, factorizing, applying simultaneous equation. Can either be in physics or it can be in maths, but a learner who's good in algebra actually is good in maths because will be able to answer other questions. Like when you talk about things like inequalities, they also applies to functions and graphs. They also applies to sequence and series. They also applies to differential calculus. So you need to be able to know these things. Algebra is the key. So this is one of the topics that most learners need, especially all the learners. You need to make sure that you get a lot of marks from algebra. I know in most of the papers, it's around the marks in algebra that just around plus or minus 25, plus or minus 25 marks. So you need to make sure that you get good marks on algebra. I will create another video where we focus only on algebra, but here I just want to address things that makes learners not to get good marks. Number one, under algebra, this is grade 11 work. This is grade 11 work. Number one, a learner should be able to factorize. Factorization in algebra, it is the key. Under that, you must be able to solve expression using quadratic formula. Thirdly, you must be able to solve inequality expressions where we're using value of x where the expression is greater than 0 or is greater or equals to 0. These are regarded as the inequalities. These are inequalities. If you want to score good marks in paper 1, you need to make sure that you go through this. Then again, you need to be able to solve problems that are involving surds. Problems that are involving surds, ladies and gentlemen, are very, very, very important. Problems that are involving surds are very important. Okay, I just want to reduce the size of this. Okay, problems that are actually involving surds are very, very, very important. Okay, let me do this on the thickness. So, okay, can I use, let me check this. So problems that are actually involving surds are very important. For example, we know we have most of the questions where they say solve for x and square both sides. I'm saying by that involves a such expression. For example, you have something like this: x minus 4 equals to 8, where you need to remove the square root. These are some of the questions that arise in the exam, but learners forget to check their solution. Learners forget, they solve, but at the end, they do not check their answers, whether they satisfy the equations or not. When you are squaring both sides, the answers that are going to get, if let's say you get x equals to 2 or x equals to 8, you need to check, you substitute these answers, these roots into the expression to check if they satisfy, so that you can be able to restrict or not restrict. Let's say maybe x is not equals to 2. You have to indicate that this is not equals to 2. Then as a result, x is equals to 8. Imagine out of 4 marks, you end up getting 3 by not checking your work. So you need to make sure that when you are solving, you check your work. I will create a video for algebra only, but I wanted to address something very important here. Again, you need to familiarize yourself with exponents. Exponents from grade 11 are very important. One must be able to use exponents from grade 11. And exponent from grade 11, again, simultaneous equations. I want to address some of the misconceptions behind simultaneous equations. I'll talk about them. The errors that most learners do when they are solving simultaneous equation. Again, the issue of nature of roots, where we talk about the discriminant nature of root, or when we are considering what you call the discriminant nature of root, which actually address what you call the discriminant. So we'll talk about this discriminant where we use the delta. So we know when roots are real. So when we have real roots, what do you mean by roots that are real? Roots that are real are roots that can be found on the number line. They exist. So if the roots are real, it means the discriminant should be bigger than 0. But if the roots are equal, the discriminant should be equals to 0. If the roots are equal, the discriminant should be equals to 0. But if the roots are non-real, the discriminant should be non-real roots. Discriminant should be less than 0. Guys, it's very important to know this. And where do we actually get discriminant? We know discriminant, it's b squared minus 4ac. We'll talk about this. Again, simplifications of fraction. Most learners, they do not get good marks because they forgot on how to simplify fractions from grade 9. This was grade 9 work, or even grade 7 work. Imagine in grade 7, they used to give you something like this. Let's say they say, simplify the following expression. Simplification of a fraction. Imagine you have 1/2 plus 3/5. This was grade 7 work, how to simplify fraction. You need to remember this. Imagine, let me show you how to simplify fraction without having to look for the lowest common denominator. What you do is you just look at your denominators. Denominators are these ones, these are the numerator. You multiply these denominators, you multiply them. So you're going to have 2 multiplied by 5, which gives you 10. After multiplying, you do this. You just multiply, as if you are cross multiplying, but you must start this side first. You cross multiply here. This is the first one. Then now you cross multiply this one. So what you do, you cross multiply 1 multiplied by 5. This gives us 5. This gives us 5. So you get 5. Okay, sorry. You get 5. You just get 5 plus, there's a plus here, 2 multiplied by 5, it's 6. Then now you work this out, 5 multiplied by 6, it gives us 11/10. And again, guys, most of you in the exam, sometimes you do this in using your mind. For example, someone can say 2 times 5, 2 times 3, it's 5 instead of 6. So you need to confirm your work. Don't just, like, we know we are not perfect. Some of you fail because you are not checking your work. You need to confirm your work. Being able to simplify expression like this, we can change and say, okay, what if now you are able to use 1/2? What if now you have 1/x, and now here you have 1/y? How do you simplify this? You still do the same simplification of fraction. You multiply your denominators. X multiplied by y, because these are unlike terms, this becomes xy. Then you cross multiply here, 1 multiplied by y, this gives you 1, plus y, I'm saying x multiplied by y, by 1, this gives you x. We know you can manipulate this because 1 plus 2 is the same as 2 plus 1. So in addition, you can start with any variable. So this is the same as x plus y divided by xy. So this is what you need to know when you are dealing with expressions. And guys, there is these questions which you call them the word problems. I think in most of the exam, particularly the Limpopo question papers, they usually like to ask the word problem. But I wouldn't say they will ask it or not ask it. But I will advise you to do the word problem maybe a day before a day before the exam. You just look at the word problem. Don't just focus on them now. You just look at this a day before the exam. But particularly, ladies and gentlemen, factorization, quadratic formula, inequalities, squaring of both sides, exponents and surds. Remember, exponents, we need to know that when you are multiplying two exponents that have the same base, I'm going to say same base, you take one base and you add the exponent. This is the reason why we say x multiplied by x is x squared, because the base are the same. We take one base and we add. But now, also for division, when the base are the same, we take one base and we subtract the exponents. You need to be able to know the laws of exponents and surds. Very, very, very important. For example, the square in terms of surd, the square root of a times b is equal to the square root of a times the square root of b. So this is very important when you are dealing with algebra. Ladies and gentlemen, you need to make sure that you get lot and lot of marks on this. Before we move on to the next chapter or the next topics, I mean to say, there is something that I actually want to address under algebra. Most of the learners, they take algebra for granted. A learner will say, since there is this formula, let me write it down so that I can be able to explain it. Since there is this formula called a quadratic formula, I don't have to practice this topic. I'll just go and write it. As long as I'm given a formula, a quadratic formula, square root minus b over b squared plus or minus the root of b squared minus 4ac divided by 2a. Right, guys, I need to tell you something very important about this. It's not bad to use a quadratic formula, but most of you, there's something that I actually encountered with most of the learners. They're failing math because of not using the formula sheet. Imagine a learner in the examination. He or she is provided with the formula sheet, but write the exam without having to look in the formula sheet. Ladies and gentlemen, imagine this. This is the formula sheet, like it is a quadratic formula. But a learner who's in grade 12 or a learner who's solving algebra, because he's used to this formula, he end up without having to check in the formula sheet, then he start doing this. He or she start doing this. This is what we actually see in most of the exam papers. Imagine the learner says x equals to b plus or minus the square root of b squared minus 4ac divide by 2a. Already, this is not the formula because you did not divide everything by 2a and your b is not negative. Obvious, when you start substituting here, you already got 0 because of not checking your work. So in order to improve your grades, you need to always keep on checking the formula sheet. Guys, you are not mathematicians now. You are not math. That's why they provided you with formula sheets so that you can use them. Stop memorizing formulas, especially quadratic. There are formulas that you need to know to memorize. There are formulas that are actually provided for you. These are the things, or these are the misconceptions that causes learners to fail maths. Look at the formula sheet, use the formula sheet. It's not wrong to use a quadratic formula. You can use a quadratic formula even if the expression has factors. But I want to address something very important. I'm talking about those learners who says, no, I don't know or I don't like factorizing. I'll keep on using a quadratic formula. The problem arises when you are dealing with expressions like inequalities. Because under inequalities, you have to factorize your expression. If it's not factorized, you need to write critical values. Now, I want to address some other things that most learners do when they are solving algebra. Ladies and gentlemen, this topic is one of the easiest, but most learners takes this topic for granted. So you need to make sure that you are with me. Right, now let me explain, because I want to spend time on algebra, because I know algebra, it is the key of all other topics that I want to address now. So I want to talk about them. So let me erase them. Right, ladies and gentlemen, these are some of the misconceptions that most learners do in answering algebra. Make sure you use the formula sheet. Use the formula sheet. Do not memorize the quadratic formula. It's provided for you, which means there are other formulas that you need to memorize. For example, to know the for example, in financial maths, the formula where you have to convert nominal to effective or effective to nominal. These are the formulas that you need to memorize, rather than trying to memorize a quadratic formula. Imagine a learner writes an exam without having to look at the formula sheet. Already, you can see that the learner, but it depends. Some do not look, but they end up getting good marks. But make sure you check. You are not perfect. Make sure you check. Now, I want to address something very, very important, especially under this, right? In most of, like in algebra, actually, we are dealing with quadratic equations. Solving quadratic equations. We know a standard, you must be able to check whether that quadratic equation you're solving, is it in a standard form? And we know the standard form of a quadratic equation is ax squared plus bx plus c. So this is the quadratic. So if we are solving this, maybe it has to be equated to 0. Ladies and gentlemen, you need to make sure that when you are given a quadratic, check if your quadratic equation is in a standard form. Standard form. The ax squared, the one with the x, coefficient of x, and the c should always be like this. Now, this is what you need to be able to know or to consider when you are solving problems, right? Because you know, most learners, they end up coming up with this thing of saying, no, as long as there is an expression at the middle, this might be always. Imagine an expression coming, maybe you are given this kind of an expression, 2x squared plus 4 minus 8x equals to 0. You know, we have such learner who says, no, since I have 3 terms, this, as long as this is the middle, it's always my b. It's wrong. It's not the b, because the equation is not in a standard form. Remember, sometimes an examiner can trick you. You need to check if the equation is written in a standard form. The ax squared, the bx, and the c. These are some of the misconceptions that learners do, to say, as long as I have an expression at the middle, it's always my b, which is wrong. Always check that the equation is in a standard form. That will help you to get good marks. Always check your work. Then another thing is this. When you are dealing with factorization, remember factorization, it means you have to factorize. And factorizing, it means you must first check, is the equation that I'm given here, is it in a standard form? Ladies and gentlemen, if it is in a standard form, then I can be able to start with factorization. factorization. For example, let me say you are given this expression. Let's say you are given this expression, x squared minus x minus 12 equals to 0. First of all, when you are solving, you need to make sure, check whether the equation it is in a standard form. Already the equation is in a standard because it is the ax squared, the bx is there, the bx is there, and the c is there. So this is in a standard form. Then if it's in a standard form, as long as there is 0 this side, you can now make 2 pairs of brackets. And guys, I want to talk about this because these are some of the misconceptions that learners do. Remember, when you are factorizing yourself, you have to check your work. Remember, you do not need any memorandum to check or any marking guideline to check for your answer. If you really understand what you are doing, you can easily know that I got it right because you confirmed your work. Most learners do not confirm their work. For example, here we need to factorize. We need to get the factors of x squared here. Obvious factors of x squared, we are going to have x and x. Now, ladies and gentlemen, this is very important. What is the coefficient of x? What is the b here? The b is 1. Now, look what I'm going to do here. This is very, 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 very important. Here, we are going to look at the factors of 12. We want the factors of 12 here. That will give me 1 or -1. Ladies and gentlemen, we still have those learners who don't understand what we mean by factors. I'm telling you the truth. We still have those learners who doesn't know what are the factors of 12. Factors of 12 are those two numbers. When you multiply them, they give you that number. We are not talking about when you multiply. Imagine a grade 12 learner saying factors of 12, 8, 10, and 2. So you can easily see that this learner do not know anything about factors. These are some of the misconceptions that learners do. 10 multiplied by 2 is 20. So these are the factors of 20, not 12. Please, you need to make sure that you check your work. I know because these are some of the misconceptions that learners do. These result to a drop in marks. They end up not getting good marks because of these things. Now, here we are going to do this. We are going to look at the factors of 12. That will give me 1 here, right? -1. Let me show you how to do this. This is one of the easiest. Remember, listen to me. The factors that we are going to use there, they must satisfy the coefficient of x, they must satisfy this x squared b, and they must also satisfy the sign here. Listen to me very well. The value that we are going to put here, it must satisfy the b, and it must also satisfy the sign. What does this mean? First of all, we're going to do this. We're going to say whatever the factors that we're going to put here, let's now look at the sign here. What is our sign? Our sign, where there is the C, it's negative. What does this mean? It means we need to put the signs here. When we multiply the signs, they have to give us negative. And we know negative is formed when we use opposite signs. If you use negative and positive, it will be negative. But if you use same sign, they will give us positive, which means we already know that the signs that we're going to use here, we're going to use opposite signs because negative times positive is negative. So that is what you need to understand, right? So now we are going to look at the factors of 12 that will give us 1. Already, factors of 12 that will give me 1, it's 4 and 3. 4 and 3 is the factors of 12 because 4 multiplied by 3 is 12. 4 multiplied by 3 is 12. But what if I use 6 and 2? 6 and 2, yes, are the factors of 12, but there is no way I can manipulate this to get 1. So now already it means I have to use 4 and 3. And within this 4 and 3, I have to use this opposite sign to get -1. Obviously, it means 4 should take minus and 3 should take plus. Then you confirm. Negative multiplied by positive. Negative multiplied by positive, it's negative. It's satisfying the sign here. Since it's negative, means correct. 4 multiplied by 3 is 12, which is fine. So what is minus 4 plus 3? It's -1. So all the time, your expression must satisfy the middle term and it must satisfy the last term. Already by so doing, you're going to have -4 and 3. Then you start doing your solving, that x minus 4 equals to 0 or x plus 3 equals to 0. Then this becomes x equals to 4 or x equals to -3. And sometimes showing this step enables learners to know that when a number or when an expression passes through an equal sign, the sign of that expression changes. That's why in most of the cases, you find that from here, a learner says x equals to -4 or x equals to 3, which is already wrong because they do not check their work. You need to make sure that you check your work, ladies and gentlemen. You check your work. You do not just solve and solve. You need to check your workings. This is algebra, and you need to make sure that you spend more time practicing algebraic expression, algebra, quadratic formula, always writing the expression in a standard form. It's very important. Again, there's these other things that learners do when they are solving algebra, and which is wrong. Imagine you're in the exam, you're given this expression, x into x minus 2 equals to 8. Then the learner starts saying, oh, it means x is 8 or x minus 2, it's already 8. Then x equals to 8 or x equals to 10. This already, it's wrong. This is 0. This is wrong. You cannot do this. You do this only when there is 0 here. If there was 0 here, if we had x into x minus 2 equals to 0, that's where you can do that. Because there is not 0 here, it means you must first transpose this to the left-hand side. So which means you must rewrite this, you expand this. You expand this by saying x squared minus 2x equals to 8. Then you transpose the 8 to the left-hand side. That's where you solve. Remember, if an expression does not have factors, already you must go straight to a quadratic formula. Usually we use this if they say round to what decimal places. And another thing, guys, that is very, very, very important, it's sometimes you might find that you are solving an expression and it's not, you do not get factors so easily. You do not get factors so easily. What do you do, guys? You cannot say, because they say solve for x, and you can see that you are not getting factors fast. You are not getting factors so fast. What do? Already, you cannot just leave the question or you factorize incorrectly. What you do is you can still use a quadratic formula. If it's an expression that does not require you not to use a quadratic formula, you can still use a quadratic formula. At the end, you convert your expression. You convert your expression. For example, remember, guys, I'm not saying people must keep on using quadratic formula, but imagine you factorized and you got the answers incorrectly so. And someone used the quadratic formula and got the answer correctly. Remember, look at this. If we have x squared minus x minus 12 equals to 0. I'm not saying people shouldn't use factorization. And imagine here, we factorized. This was x 4 and 3 minus, and plus. Remember in the exam, there's a mark for factorization. There is a mark for factorization because in the exam, if you use a quadratic formula in some instances, they penalize for not being able to factorize. So now, also we're going to say x minus 4 equals to 0 or x plus 3 equals to 0. I actually encourage learners to show this so that they are able to change the numbers to the signs. So let's say supposed to get 1 mark there, 1 mark there. Let's say this is 3 marks. Now look at this. Imagine you are factorizing, or maybe you are having expression that the coefficient of x squared is not actually 1. I wanted to look on the other expression. Okay, let me look for, I want an expression where the coefficient of x squared is not actually 1, so that I can show you that not always that, sometimes you find that you cannot just spend more time on expression that will take more of your time. Okay, let's just go through this again. Let's say you have x squared minus x minus 12 equals to 0. Already the equation is in a standard form. Since in the standard form, you know A, it's 1 is the coefficient, the B, it's -1, and the C, it's -12. We still have those learners who are using quadratic formula, but still get wrong answers because of not confirming. Right, now, imagine you do this. You're going to say, okay, yeah, first of all, you go to the formula sheet and you copy the formula. So x equals to minus b plus or minus the square root of b squared minus 4ac. Everything, very important, divided by 2a. Then now, you write the formula, then you substitute. Already there's a minus, so you're going to say minus open brackets. What is your b? Minus 1 plus or minus the root sign into open bracket. What is the b? Minus 1 squared minus 4 into the a, it's 1, and the c, it's -12. Guys, you need to check your work. Don't just substitute and leave. Before you move on to the next step, check if you have substituted correctly first, then you move on, because you are not perfect. You can, there might be mistakes along the way. So negative and negative, this gives us 1 plus or minus. You do this, you just put the root sign here. You say divide by 2 times 1 is 2. Then you are going to do this. You go to your expression, you press you work out the expression inside the brackets, So you're gonna say minus 1 squared without putting the root sign. Minus 1 squared is just 1. I mean, you're gonna work it out. Then now, what will this give you? So I think this will give you 49. You're going to have 49 here. Then you're going to say, okay, fine. You expand this. This will be x equals to 1 plus the root of 49 divided by 2, or x equals to 1 minus the root of 49 divided by 2. Then now, you know this, most of the learners, they say, I'll just use a calculator just to give me the answer from me up until here. You need to check your work. So here you're going to say 1 plus the root of 49. Obviously, the root of 49 is 7. 7 plus 1 gives us 8. 8 divided by 2 is 4. Then this one, 1 minus 7, then this gives us 1 minus 7 is minus 6 divided by 6 minus 3. You see that the answer is the same, but they did not want you to use a quadratic formula. Already, what you do this, since you have x equals to 4 or x equals to minus 3. We do not want to forfeit marks here. What you do if you have used a quadratic formula somewhere, you take these numbers back. Listen to me very well. You take these numbers back to where they are. I'm not saying you must keep on doing this. I mean, on a case where it's not, if you don't get factors faster, you return these numbers back. So if you're going to have x minus 4 equals to 0, same applies this side. X plus 3 equals to 0. The way this expression, you copy this expression, which is x minus 4, it's here, you copy even this one there, you already have factorized. Even if you got fractions, let's say you got x equals to half this side, or x equals to minus, let's say minus 3 over 4. What you do, you first get rid of this by cross multiply. So you're going to have 2x equals to 1. Then you transpose this. So this will be 2x minus 1 equals to 0. Even this side, you do cross multiplication. It's going to be 3x equals to, then you transpose it back. this will be 3x plus 1. So already you are going to factorize. You make factorization, then you're going to have 2x minus 1 and 3x plus 1. So this is what you need to know when you are dealing with this. I'm not saying you must keep on doing this, but in the case where you are not getting factors faster, you can still do this. Remember, you need to practice as many questions as possible. Most learners say, no, I'm not going to practice quadratic formula. I'm not going to practice. And they incur a lot of mistakes here when they're doing the substitution. Check your work. When you substitute, check your work. Check what you are doing, ladies and gentlemen. I assure you, you'll get good marks. You will get good marks. You will get good marks when you are solving this. Then the other one, it is the issue of inequalities. Remember, it's what most learners are struggling in, inequalities. It's fine. I will create a video based on algebra where I will address this. Then the other thing is the issue of squaring both sides. When you are given expressions of squaring both sides, you need to check your work. Remember, these are those expressions where we know we square both sides in order to remove the root sign. For example, let's say you are given this. You have to solve for x. The square root of, just an example, x minus 1 plus 1 equals to x. Number one, before you start squaring both sides, you cannot square both sides. You need to remain with the root sign expression only. It means you have to transpose x to the right-hand side. And since x is positive, it means it's going to become negative. Then you're going to say, okay, right, you have x minus 1. This side you have x minus 1. Then you can now square both sides. The reason of squaring both sides is to remove the root sign. So this will give you x minus 1. Then, remember, sometimes you need to show all your workings. This enables you not to incur a lot of mistakes. So you're going to have x minus 1. Then you start expanding this. X multiplied by x, this is x squared. X multiplied by negative 1, it's negative x. Then you're going to have negative x and plus 1. Then you simplify this. This will be x minus 1. You're going to have x squared minus 2x plus 1. Then you group like terms. So you can remain this, you can let this to be 0 this side, which means you move them to the right-hand side. Remember, you want this to be in ax squared plus bx plus c. So you're going to start with the ax squared is just x squared. Bx is minus 2x. But now, since this also the b, when you bring it this side, it will be minus x because its sign is here. So then plus 1 plus 1. So this will give us 0 equals to what? This will be, what is this? The x squared minus 3x plus 2 plus 2 plus 2 equals to 0. So you can still write it like this as x squared minus 3x plus 2 equals to 0. Then you start doing your factorization. And before doing that, look at this. Factors of x squared, it's x and x. Before looking at this, let's look at the sign. The sign says positive, which means we have to use the same sign here. And using the same sign, since there's a minus, it means you must go through minus and minus, because negative and negative is positive. Very important. Okay. So now, what are the factors of 2? 2 is 2 and 1. So it means we're going to just put 2 and 1. Let's confirm. Minus 2 minus 1. It's minus 3. Negative and negative, it's positive. 2 times 1 is 2. Then you're going to say x minus 2, it's 0, or x minus 1 is 0. Then you're going to say x equals to 2 or x equals to 1. I'm doing this for those learners who like, you can do, but you can skip this part here. There's no need. Right, there is 1. Once you got this, you don't just leave these answers. This was out of 5 marks. You don't just leave this and say this. You need to confirm. Confirm meaning you go back to your expression. You go back to your equation here. You substitute where there is, like you substitute, you say, okay, if x is 2, you put 2 here. You put 2 there, you check whether the answer is the same. Already 2 minus 1 is 2. The root of 1, it's 1. 1 plus 1, this gives us 2. Even this side will be 2. It means this is the correct one. Now you put 1. 1 minus 1 is 0. The root of 1 is 0 plus, the root of 0, it's 0 plus 1, it gives us 0. Even this side, it gives us 1, I'm to say, even this side when you substitute by 1. So it means these are all correct. Then you continue. These are the things that learners do. They do not check their workings. You check your workings, especially when you are dealing with squaring both sides. When you're dealing with squaring both sides, it's very important to check that. And again, guys, when you're dealing with simultaneous equation, in the exam, I want you to listen to me, especially in the exam. If you are given a simultaneous equation and you try to solve for that expression, you find that the expression does not have factors. Maybe when you solve for x, it starts to give you decimals. Let's say you get x equals to 0,4 something. Just know that there's something wrong here. There's something wrong. I'm not saying that in most of the simultaneous equations, especially in the final, most of them are factorizable. If you just solve, you find that it's not factorizable, it shows that something's wrong in your expression. Go back and try to check your workings. Try to check there's something wrong along your problems. Try to go back and check, but it's very rare in the final exam to be given a simultaneous equation that has no factors or will require you to round numbers into 2 decimal places or whatever. It shows that something is wrong. You need to go back and do your workings. Actually, guys, these are the things, these are the misconceptions that I'm actually trying to address here. I will create a video for algebra only. Remember, guys, algebra, it's one of the topic where most of you guys are supposed to get good marks from algebra. You need to get good marks from algebra. Algebra, it's one of the topics that has good marks. Ladies and gentlemen, do not take this for granted. Do not take algebra for granted, because a learner who's good in algebra, he will be able to answer other questions in paper 1. Right, let's move on. Moving on, we are going to talk about sequence and series. Right, guys, this is very important. Under sequence and series, we usually call this sequence from grade 11, they will call it a number pattern. A number pattern. Very important. It still continue from grade 11. A number pattern is just, when we say a sequence, we are talking about a sequence of numbers or numbers that, or expressions that are actually written in consecutive order. For example, if I say T1, comma, T2, comma, T3, comma, T4. This is a sequence. So you need to differentiate between a sequence and a series. If I still, this is term number 1, term number 2, term number 3, term number 4, maybe up until the last term, which you call it the nth term. This is a sequence, or it's a number pattern. But once I start doing this, T1 plus T2 plus T3 plus, once I start adding, this is no longer a sequence. It is a series, because you are adding terms. So in the exam, you must be able to know, is this a sequence or is this a series? Be able to differentiate that, right? Ladies and gentlemen, in terms of your syllabus, there are 3 kinds of sequence that you need to know. You need to be able to know the sequence and their properties. How, like, their properties. Let me just talk about and their properties. Number 1, we have what we call an arithmetic sequence. It's not the first time you have learned this. An arithmetic sequence in grade 11, they used to call it a linear pattern. A linear pattern. So when you are given a sequence, remember, how do you see that is a sequence? It must be given in, what is this? is it a semicolon? Is it a semicolon? In commas, actually. It must be written in commas. So now, what does this mean? It means that once you are having expressions that are in this form, then you know this is a sequence, ladies and gentlemen. So there are three kinds of sequence in your syllabus. Guys, you can get total here. You can get total in sequences. Series. This is one of the topic with good marks, because with easy marks, because you know they either will give you an arithmetic sequence or a quadratic sequence that you have learned in grade 11, or a geometric sequence. If you do not get any three of these, it means there is what you call combination of sequence. Maybe they combine arithmetic and quadratic on one sequence, or they combine geometry. It depends with the question. It depends with the question. Number one, when you say this is an arithmetic sequence, I think, guys, in this chapter, you need to be, once you know what you're doing, it will be easier for you to answer the questions. Let's say you are given this T up until Tn. Sometimes you need to be able to know, okay, fine. If you take these two terms, listen to me very well. If you take term number 2, listen to me. Term number 2, you subtract term number 1, and you get the answer here. And you also take term number 3, you subtract term number 2, you get the answer here. Then you also take term number 3, term number 4, subtract term number 3, you still get the answer. As long as the answers that you got when we call it a first difference, especially if you got a common difference. As long as there is a common difference, this answer here and this one, and these ones are the same. As long as they're the same, when you subtracted initially, then this is an arithmetic sequence. And within this arithmetic sequence, the answer that you got here, these answers that you got here, the answers that you got there, we call them the common difference. And this common difference, it's represented by the D. So it means when you are given a sequence, once you subtract for the first time and the answers are the same, then you know you are dealing with an arithmetic sequence or a linear pattern. Be careful, guys. We do not take the first term and subtract the second. We take the next term, subtract the previous one. We take the next, it's just like that. So it means if the answers are the same, we call this a common difference. So then you must be able to know the general formula for this, which you call the nth term, which is Tn equals to A plus n minus 1 times D. And the A is the first term, T1. This is your first term. This represents the term number 1. The first term, this is your first term. The D is the answer that you got here. The common difference, that you got here. This is your D, and you can still be able to use that. Very important. Very, very, very important. Then now, right, this is when you are given an arithmetic. Remember, you need to know what you are actually doing. For example, it might be in the case where you are just given, expressions where you do not know they are, let's say, you are given expression where you do not know, like you have unknowns values. For example, let's say you have T1, T2, T3, T4. Let's say the first value is X here. And the second value is Y. Let's say, it's just an example. And the third value is, let's just say 11, it's just an example. Then this one is, let's say it's okay, let's say it's just 20, it's just an example, it's 20. And they say solve for x and y. So it's easy. Or it's solve for x and y if this is arithmetic. So what you do, if you are told that it's an arithmetic, what do you know about arithmetic? This is T1, T2, T3, T4. So with the arithmetic, you can do this in two ways. Try to get the difference. Obviously, what are you going to do? Next term, subtract. So this will give you y minus x. T3 minus T2, this will give you 11 minus y. 20 minus 11, this will give you 9. So what does this mean? If these and arithmetic, these must all be equal. So it means it's either y minus x is the one that is equals to 11 minus y, or 11 minus y should be equals to 9. So any of these. So you see, these and these and these must be equal. So it's either you equate this or you equate the other. The answer. Okay, guys, I apologize. I just had connection issues. Let's continue. Like, yeah, I was just telling you about how to actually deal with, as long as you know what you actually do, like you know what you are doing, then it will be easier to answer questions. Because like as I was saying, what was the example? What I was saying, we had the x, y, 11 and 20. So we can say, if we take T2, which is y minus x, the answer will be the same if we take T3 minus y. Or we take T3 minus T2, the answer will be the same as when you take T4 minus, which is just be 9. So you can just solve, then we can solve for this simultaneously. So we can say in the first equation, let's group the like terms. We can transpose y this side. So this will be 2y minus x equals to 11. Then we still call it equation 1. Then we come this side, we solve for y. So we're going to say 11 minus y equals to 9. We transpose 11, so we're going to have minus y equals to 9 minus 11. So we're going to have minus y. So this will give us minus 3. And if it's minus 3, then no, it will be minus 2. I apologize. So this is this will give us minus 2. So then we multiply both by negative, then y equals to 2. So then you have the y equal, so you can now come to this. And so you see, it's all about knowing what you are doing. When they told you what to, like, is this an arithmetic or is it a geometric? Then once you know what you're doing, it's all about algebra, manipulation of variables. You can still get the answer. Right. All right. We'll talk more about this. I just want to show you, like, I want to address how can actually get good marks from this. How about quadratic? Quadratic means you have to say, okay, fine. If you're given T1, T2, T3, T4, T5, and so on. Now, they just told you this is just a sequence. What you do, you try to get the difference for the first time. Let's say when you get the difference, the answers are not the same. You're getting different values. So the values are not the same. You're getting different values. Remember, let's call this the first difference. First difference. When you subtract for the first time, T2 minus T1, the answers are the same. I'm saying T2 minus T1, T3 minus T2, T4 minus T3, T5 minus T4. You find that the answers are not the same. Already, if the answers are not the same, it means it's no longer arithmetic. Because if it's arithmetic, it must have the first the common difference. Then now you try to do this for the second time, and when you try to do this for the second time, then you end up getting the same value. You're getting the same value. The values are now the same. And what does this mean? It means now this is a what? Second difference. As long as there is a second common difference. As long as there is a second common difference, it shows that you are dealing with a quadratic equation. This is a quadratic sequence. I mean to say quadratic sequence, which is the general formula of an squared plus bn plus c, which we'll talk about it later. Then now, within this, you need to know something very important here. You need to know something very important. When you are dealing with this quadratic, you need to know that, remember, what did you do here? You had the original sequence. This is the original sequence. This is our original sequence of a quadratic. And this is the another sequence, which is a first different sequence. And you also have the second common difference, which is a sequence also. And within this, we have to say, okay, the second common difference, the value that you're going to get here, you denote this always to 2a. And the first term that you're going to get in the second sequence, it will be your 3a plus b. We'll talk about this, 3a plus b. Then your first term in the first sequence, that is, will be your a plus b plus c. So this is what you need to know about a geometric sequence. I'm saying quadratic sequence. For example, let's assume we have this, we're given this sequence, we have 6, 11, these are just free marks, and 22, is it 22? 22 and 39. Let me check if something's not wrong here. Okay, fine. Let's try to get the difference here. 11 minus 6. Remember, I said this. Remember, this is T1, T2, T3, and T4. 11 minus 6. This gives us 5. Then 22 minus 11. This will give us 11. 39 minus 22, this will give us 17. You see that you subtracted for the first time, the answers are not the same. So it shows that it's not arithmetic. When you do it for the second time, 11 minus 5, this gives us 6. 17 minus 11, you see that this is the what? This is a quadratic sequence. And since it's a quadratic sequence, this is going to say, oh, this is the second common difference, is denoted as 2a. This is the first term in the first different sequence. This is 3a plus b. This is the first term. This is the a plus b plus c. Then this we're going to say, okay, it means 2a should be equals to 6. We divide by 2, then the a equals to 3. Then you now say 3a plus b should be equals to 5. Where there is a, you substitute by 3, and you're going to get this. When I have 5, this is 9 plus b equals to 5. Then the b becomes 5 minus 9, it becomes minus 4. Then lastly, you're going to say a plus b plus c will be equals to the first term, which is 6. Then now, what is the a? 3, the b is minus 4, plus c equals to 6. This gives you minus 1 plus c equals to 6, and c equals to 7. Then you come to this equation now and say, okay, now I know the a. What is the a? Tn, the a is 3n squared. The b is minus 4. Then the c is 5. It's 7. And before you move on to the next question, to confirm this is the correct answer, remember this is term number 1. It means the n here is 1. So you can just take n here, where there is n, you substitute by 1 here. So this will be 3 into 1 squared minus 4 into 1 plus 7. Just to confirm, the answer is 3 minus 4 plus 7 is minus 1. This gives us minus 1. This gives us 6. You see that this is the correct one. You must write. You need to be able to know this. These are just the basics. This need you to understand. And mind you guys, let me show you something very important when we're dealing with quadratic. In the original sequence of the quadratic, if we do away with the first, do away with its sequence, it means that the first difference now is the remaining sequence now is now becoming an arithmetic. This is now becoming an arithmetic sequence. It's now becoming n. So it means in a what? In a quadratic sequence, there is an arithmetic sequence. We'll talk about this. I'll create a video, but I just want to show you where to actually get good marks from this. Then again, let's move on. Let us move on. Let us move on. Remember, practice makes perfect. Practice makes perfect. Then the last one, it is the issue of the geometric. How do you see that this is a geometric sequence? This is a geometric sequence. Let me just talk about it. Right. Sometimes in the exam, they're not going to tell you what type of a sequence is this. So it is your duty to check whether it's linear or arithmetic. Is it quadratic or geometric? Say example, you're given T1, T2, T3, T4, T5, T6. Then you say, okay, you try to do this. You get the difference. Once you get the difference, you find that the answers are not the same. You're getting different values. You're getting different values plus my, no, you're just getting different values here. But now when you do it for the second time, still the answers are not the same. You're getting K, P, so it means W. So you're just getting different values. Yes, I'm just saying we're getting different values. So you see that already. It's not arithmetic because the first difference are not the same. It's not quadratic because second difference are not the same. So what does it mean? It shows that it might be a geometric. And how do you confirm this? What you do, you now divide the ratios in terms, you now divide the terms in terms of, rather than subtracting. So you're going to take T2, you subtract T1. You take T3, you subtract T2. You take T4, you subtract T3. Just like that. You take T2, divide, no, I'm going to say divide, not subtract. I apologize, guys. You take T2, divide by T1, take T3, divide by T2, T4, divide by T3, just like that. If the answers are the same, then you know this is a geometric sequence. So it means in a geometric sequence, we have what you call common ratio. There is a common ratio, which we denoted by R, which is T2 divided by T1. So when you divide terms and you find out they're the same, then we have a common ratio. That's why in the exam, they will tell you this is a geometric. Even if you have this unknown variable, you still have to do this. So it means a general formula for geometric is Tn equals to A times R to the power n minus 1. You do not have to claim this. They give you in a formula sheet. What is the A? The A is your first term, your T1. And what is the R? The R is the common ratio. When you divided the terms and that the same, then you know this is a geometric sequence. In the exam, you must check that. If they gave you a geometric sequence, if you're given a sequence that not tell you what type of a sequence that you check, ladies and gentlemen. I will address it, but I just wanted to remind you about this. That's why actually sequencing series is one of the topics that you can get lot and lot of marks. So you need to practice as many questions as possible. So now, how about now you are just given a sequence? You are given a sequence. Now, combination of sequence. Let's say you are given this T1, T2, T3, T4, T5, and so on. Now, once you try to subtract, the answers are not the same. You do second time, the answers are not the same. You divide, the answers are not the same. It means it's not arithmetic, it's not quadratic, and it's not geometric. What does this mean? You try to separate this. Take the first term, maybe create another sequence by taking the first term, leave the second term, take the third term, you create it. So it's just like that. You leave the fourth term, take the fifth term, you try to check, then you call it, you create a sequence about this, then you create another sequence by taking the remaining ones. So you're going to be T2, T4, T6, and so forth. Try to check. If, let's say, you might find that on one sequence, another one is arithmetic, another one is geometric. This is the combination of the sequence. And you must be able, when there are combination, try to check. In the first sequence, look at this. This is 1, this is 3, This is 5. So you're dealing with odd numbers here. So it means you need to be able to know, okay, you are dealing with odd numbers. Here it's 2, here it's 4, here it's 6. You are dealing with even numbers. For example, if they say determine term number 18, you need to check. Term number 18 is an even number. So it means you will have to get this term under this sequence. But if they say determine term number 17, term number 17 is an odd number. It means you have to get it under this sequence. So you need to not be able to check whether you're dealing with odd numbers or even numbers. The terms on its own will tell you which sequence you need to answer that question. It's very important, guys. Remember, practice makes perfect. I will create another video to address the sequence in series. Remember, guys, by knowing what you are doing, it will be easier for you to answer the questions. It will be easier for you to answer the questions. It will be easier for you to answer the questions. Remember, practice makes perfect. Practice makes perfect. Now, let us move on the issue of series. Remember, I said series is when you are adding terms, T1, T2, T3, T4, T5, and so on. Now we are summing. We're getting sum to n because we're adding n of them. Listen to me. Here, there are two types of series. We only have arithmetic series and geometric. There is no quadratic series. Remember, the only difference is that this is a sequence, there is a series, but the application is the same. An arithmetic sequence is where we subtract 10. Same applies with geometric, a series. Series, even if it's an arithmetic series, if it's an arithmetic, means it must have the same common difference. Even if when you subtract, whether you're adding or you're dealing with sequence, the approach is the same. T2 minus T1, T3 minus T2, T4 minus T3. As long as the answers are the same and you are adding term, it's an arithmetic, but it's an arithmetic series. Okay, it's an arithmetic series with the nth term. We still use the nth term of a plus n minus 1. But this time around, we are summing. We need to know if we add this term, what will be the answer? There is a formula for determining the sum. When you are dealing with series, so it means you are sum to n, which we use n over 2 into 2a plus n minus 1 times d, or we can use as n equals to n over 2 into a plus the last term. Let's say we're given a last term. You know the last term, the nth term, you know it, then you're going to substitute. Remember, this is for arithmetic sequence. That is for arithmetic sequence. But if we take T2 and we divide by T1, T3 divide, even if it's a series and the answers are the same, then it's now becoming a geometric series. So it means for a geometric series, we use as n equals to a into r to the n minus 1 divided by r minus 1. But we use this when r is bigger than 1, when r is bigger than 1. But now, guys, within this, I'll address the issue of the series, the sequence in series. We still have another one, 1 minus r to the n over 1 minus r, where r is less than 1. And under this geometric, there is a part where we talk about the sum to infinity, which is equals to a over 1 minus r. And this sum to infinity in the formula sheet, there is a condition that they usually put here between minus 1 and 1. This is the condition where we use when the series converge. When they say, what are the values of x, will the series converge? For the series to converge, the value of r should always be between minus 1 and 1. So it means if they say in the exam, will the series converge or diverge? The series will only converge if the value of r is between minus 1 and 1. But if it's not between that, if the r is bigger than 1, it's diverging. It's going to have a divergence. The series will diverge. It will not convert. And remember, sum to infinity applies to geometric not arithmetic. Applies to geometric. I will talk more about this. I just wanted to remind you that you can get is the free marks here, especially guys being good in sequence and series, being good in algebra, then already you are accumulating a lot of marks. Whether it's a sequence or it's a series, arithmetic, the property is the same. When you subtract for the first time, the answers are the same, and you know we're dealing with then arithmetic sequence or series. Arithmetic sequence or series. Then we are going to talk about the issue of the sigma notations, where we are dealing with sigma notations. I think I will create a video about that. So I will create a video about the sequence and the series. Let me just, because I want you guys to get good marks. Once you read the question, they say, calculate the sum to infinity. You must know that you're already dealing with geometric. Sum to infinity applies to geometric series only. We do not have sum to infinity on arithmetic series. It only applies to geometric only. Once they say determine the sum to infinity, you know you are dealing with a geometric series. Let me address something very important here. Guys, this issue of once you see something like this in the exam, once you see something like this, sigma, this represents sum of term. It's just summing of term. So it means once you see this, you know you're dealing with a series. And with these guys, you need to know, for example, if we say n equals to 0 and let's say 99. Inside here, we know we have 3. Let's say it's 3n plus 5. Once you see this, ladies and gentlemen, you need to only know that you are dealing with a series. This is a series. Now, the question is one, if this is a series, what type of a series is this? Okay. Now, look at this. If I write this and I write this one here, let me write it again. N equals to 1 up until 99 of 3n plus 5. I want to show you something. Then another one here. N equals to 2 with 99 on 3n plus 5. These series are not the same. Very important, guys. When you are dealing with this, you need to always check this. You must look at the starting point. The starting point of your series, starting point. Where do you start? For example, where do we start here? This is the starting point. Where do we start? These series are not the same. So you must always check that. These are just free marks, guys. I'm only addressing things that will give you a lot of marks. I mean, free marks. Number one, if you're starting at 0, it means here you have to move from 0 to 1, 1 to 2, 2 to 3, so on up until 99. But here the starting point is 1. You move from 1 to 2 to 3 to 4 and so on. Starting point is 2. You move from 2 to 3 to 4 up until 99. So these series are not the same. So when you are given this, always you must be able to get the first 3 terms. First 3 terms so that you can be able to know whether this series it's arithmetic or geometric. But you need to be able to know something. Right, we do this. You first substitute, starting point is 0. When there is n, you put 0 because you have to start from 0. 3 times 0 is 0. 0 plus 5 is 5. So it means the first term is 5. Plus. After starting from 0, you now move on to 1. So where there is n, you put n. 1. 3 times 1 is 3. Plus 5, this gives us 8. Plus, you now put 2. 3 times 2 is 6. 6 plus 5, this gives us 11. Already we got the first. You see, I'm writing a plus to say this is a series. Not like this, not 5, then 8. If they say write down, you do not have it because it's not a sequence, it's a series. So you must show this. Now let's come to this. Starting point is 1. You put 1 now. Once you see that when you put 1, it means your first number will be 8. You put 2, your second number will be 11. You put 3. 3 plus 3 times 3 is 9. 9 plus 5, this gives us 14. You see the answers are, you see starting point is 8 here. I mean, starting value is 80. What about here? Already, since because you are starting at 2, it means when you substitute by 2, the answer will be 11. Then you go to 3, the answer will be 14. Then you go to 4, the answer becomes 3 times 4 is 12. 12 plus 5, this gives us 17. You see that the numbers are not the same. So you need to be able to know the starting point of your series. And again, knowing the starting point of your series, guys, you must also know how many terms are you dealing with here. You must know the number of terms that you are dealing with. How many terms so that you can be able. And another thing, guys, remember I said we only have 2 types of series. It's either you have arithmetic or you have geometric. Now, how can you confirm the type of a series you're dealing with? Remember, let's try to subtract. Subtracting the terms, let's start with this. Let's start, remember this is T1, T2, T3, T1, then let's get the difference. 8 minus 5, this gives us 3. 11 minus 8, it still gives us 3. You see that it has the first different, common difference, then you know this is an arithmetic series. It's an arithmetic series. Obvious, even this, all of them are arithmetic. And it's an arithmetic with the first term of 5 here, common difference of 3. But when we are looking with, when we are using this, it's an arithmetic with the first term of 8, common difference of 3. This one is a first term, like it's an arithmetic with the first term of 11, common difference of 3. So you need to be able to understand this. And within this, you must know how many terms are you actually dealing with, how many terms are here, how many terms are actually. And how do you do this? Let me show you this, how to do this. What you do, remember, this is the start value. This is your end, the finishing point. Look at what I'm going to do. To know how many terms are here, you take the top, the highest value there, it's 99. You subtract this 99 by the starting value, which is 0. Then you add by 1. So it's 99 minus 0 plus 1. It means you're having 100 terms here. There are 100 terms in this series. Then you come this side. This one, how about this one? You do the same. 99 minus 1. Then at the same time, add 1. 99 plus 1 is 98. 98 plus 1 means here we have 99 terms. There are 99 terms. How about this side? This side, for the last one, what do we have? N equals to 99 minus 2 plus 1. 99 minus 2 plus 1. Already 99 plus 1 is 100. 100 minus 2 will give you 98. So it means there are 98 terms. This is very important. It means when you're going to use this formula of Sn equals to n over 2 equals to 2a plus n minus 1 times d. In the first formula, this one, we're going to put n to be 100. This will be 100 here. Then the a will be 5. The n is 100, d will be 3. But when we're using this, the a will be 8, the d will be 3, but the n will be 99. Same applies. So all the time, guys, you need to be able to know how many terms are in the series, how many terms are in the series. And always you need to generate 3 terms. Even if they do not tell you, you generate, to be able to know that what type of a series is this. Very, very important. Series, we only have 2 types of series. It's only arithmetic and geometric series. These are just easy marks. Only when you know what you're doing, you'll be able to answer the question. But if you don't know what you're doing, then it will become a problem. You must be able to understand sequence and series. This is one of the topics with easy marks, free marks to get, guys. Free marks to get. Mahala. Only remember, practice makes perfect. Practice makes perfect. Practice makes perfect. Then, as I said, remember sometimes, if you look at the formula sheet, guys, okay, I think I will address this by a video, another video. Here, I just want to give you some tips on how to actually get an A+ in mathematics paper 1. Mathematics paper 1. Let us now move on to functions and graphs, guys. Here. Actually, in functions and graphs, let me just say, under functions and graphs, you see functions and graphs, and what is the other topic? And calculus. This, let me say calculus. This is one of the topics that has a lot of marks. So let me try to talk about this. Let me try to talk about this. Number one, usually functions and graphs comes in three equations. Sometimes they can give you a hyperbola alone, or they give you a, yes, let's say a hyperbola alone. So they can give you a hyperbola, maybe with straight line, or with right hyperbola or parabola, and the inverse, I'm saying exponential or straight lines. Number one, when you are dealing with functions and graphs, you need to know the standard form. Particularly for the first one is the hyperbola. Number one, we know in a hyperbola, guys, the standard form of hyperbola is A. Okay, I apologize. The standard form for a hyperbola it's A. I already created a video for hyperbola, guys. So I will encourage you to go through it and try to answer the questions. Okay, now, so it's A. Okay, sorry, guys. So which means where I'm writing this, and I need to take this. Okay. So actually, let me just say, in terms of this, because already I have addressed the part of the hyperbola. Okay, I apologize, guys. Apology. Okay, right. Now, in terms of what I was just saying, because there's a video that I already created for functions and graphs, particularly on hyperbola, I'll just try to summarize to remind you on some of the things that are easy to get here. Number one, guys, because already I have created a video on this, so you can go through the functions and graphs and the hyperbola. Okay, let me just try to raise this. Okay, number one, guys, I think here, this is one of the easiest. Number one, you must know the standard form. I think I've expressed it that it's y equals to a into x minus p plus q, where it will keep on changing. Remember, the p and the q is the shifting. Right, number one, we know, and these are easy marks, guys. When you are sketching hyperbola, you know you must get asymptotes. You must get the x-intercept, where you let y to be 0. You must get the y-intercept, where you let x to be 0. Then these are just additional where you can determine the domain, the range. Remember, the asymptote for hyperbola, it's two of them. It's for x and y. So it's x equals to p and y equals to q. You always change the sign for the denominator, but this one does not change. Then in terms of the domain, already this has easy marks. We're going to say x is an element of real numbers. You only restrict your asymptote. X, yes, x must not be equals to p. Then followed by this also x, I'm saying y. Sorry, y is an element of a real number. Y is an element of real number. These are just easy marks to get, guys. Y is an element of a real number, but y should not be equals to 0, equals to q. The y, I'm saying the y, not the x. And again, you must also familiarize yourself with the equations of the lines of symmetry. Remember, there are two. There's that one of a positive gradient, and so it's y equals to x plus c and y equals to minus x plus c. And you need to use the asymptotes to get the value of c. I think this one, guys, you need to make sure that you get good marks here. To get good marks, these are just free marks to get. Free marks to get. I don't want to spend more time on it because there's a video that I already created for the hyperbola together with the straight line. So make sure that you go through that on your own. You familiarize yourself with the hyperbola because this is straight, it's straight and forward. So I want to spend more time on this. Make sure that you go through it on your own, ladies and gentlemen. I like this is one of the topic that has a lot of marks. It's one of the topic that has a lot of marks. For example, if we have 4 over x minus, let's say 3 plus 1. First of all, what is the asymptote? Asymptote obviously change the sign for the x. So x is 3 and y is 1. So it means when you write the domain, and then you just say x is an element of real number, but x should not be equals to 3. You see, so easy. Then the range, y is an element of real number such that y should not be equals to 1. So easy. Then how about like in terms of like manipulation of variable, you know, x is to relate to y to be 0. So you transpose the one you solve for x fractions, you know, these are straightforward. There's a video that I've already created. So kindly go through it. These are just free marks, guys. Free marks to get. Practice makes perfect. Free marks. If you practice more of this, you know, you're not gonna, like you're going to enjoy the paper. Then again is the issue of a parabola. Now, again, guys, I need to address parabolas. In terms of parabola, you need to be able to know the standard form of a parabola. Usually a parabola comes into standard forms. It comes into standard. It's either it's y equals to ax squared plus bx plus c, and y equals to a into x minus p plus q. Then you know, if it is in this standard form, how do you sketch the graph? Remember, in terms of a parabola does not have asymptote. So it means when you are dealing with a parabola, you need to be able to identify this coefficient of x, the a here, is there to tell us about the shape, because if the a is a number bigger than 0, we know that the graph will have a smile face. The graph will have a smile face. It will be concave up. The graph will smile. Then when the a is negative, it means the graph will have a sad face. So these are the things that you need to know when you are sketching a graph. And guys, whether it's like this or it's like this, number one, when you are sketching a graph of a hyperbola, they need the x-intercept, where you let y to be 0. Secondly, you have to get the y-intercept, where you let the y-intercept where you let x to be 0. Thirdly, you need to get the turning point. And now, if the equation is in the first standard form, let me call number 1. If it's in the first standard form, to get the turning point, you have to get the axis of symmetry. And with the axis of symmetry, which is x equals to minus b over 2a. And guys, you can either use axis of symmetry or you use calculus. What do? You differentiate your equation. You make dy over dx equals to 0. This will still give you the same. Why? Because if we take the quadratic equation, why are we differentiating an equation to 0? Remember, we're going to talk about calculus. Calculus is teaching us about gradient. And we know where the line is not increasing, the gradient is 0. That's why when we say derivative is 0, it means at the turning point, the graph is not increasing and it's not increasing. So it means its gradient is 0. So if we make dy over dx, we differentiate y with respect to x. This will be 2ax. Then this will be the b. This will be 0. Let's solve for x. This will be 2ax equals to negative b. Let's divide by 2a. X will be minus b over 2a. You see, this x equals to minus b over 2a. It comes from differential calculus. You see, axis of symmetry. And after getting axis of symmetry, you substitute these values of x. Substitute the x value into the original equation to get the value of y. When you have the first standard form, if the graph it is in the first standard form, you use it in that way. So these are the things that will enable you to get good marks when you are dealing with, when you are analyzing a parabola. But if the equation is in this form, there is no need to do this because the P and the Q already are your turning points. The P and the Q are your turning point, but you need to be careful here. The P here, the P, if it's a minus, when you write the turning point, you change the sign all the time. For example, if you have y equals to 2 into x minus 3 squared plus 4. So to get the turning point here, you look at the sign. If there is the minus, then you may change it to positive, but this one does not change. But if it was, let's say it was y equals to, let's say, 2 into x plus 1 squared minus 4, the turning point would be minus 1 and minus 4. We change the sign here. Here it does not change. Very important, guys. These are just free marks to get. These are just free marks to get. But even if you are used to the other one, you can still expand this and write it in the form of ax squared plus bx plus c. Then you use the other approach. It's still fine. You can still use it. For example, let's say, just to confirm your work, guys, just to confirm your work, remember when you are determining the parabola, when you are sketching the parabola, we need the x-intercept, the y-intercept, and the turning point. So what you're going to do is, if you want to confirm whether, like, if you want to confirm if you have done this correctly, if this is the correct turning point, you can still write the equation and say, okay, you have 2 into x minus 3 squared plus 4. Then you convert this to a standard form of ax squared. There are many ways to skin a cat, guys. So you're going to have 2 into, let's say you're going to have x squared minus 6x plus 9 plus 4. Then you expand this, you multiply everything by 2. 2x squared minus 12x plus 18 plus 4. This will give you y equals to 2x squared minus 12x plus 22. Yes, 22. So you see, you have changed this to from being y equals to a into x minus p squared plus q to this one. So you can get the axis of symmetry. Remember, we use this only when we have a quadratic. So then what is the b? The b is negative 12. So you're going to put negative 12 there over 2 times. What is the 8? The 8 is 2. Then you're going to have 12 divided by 4. This gives you 3. Then after giving, then you substitute the equation here where there is x. So you're going to have 2 into 3 squared minus 12 into 3 plus 22. I don't have a calculator with me. It's 2 by 9 minus 36 plus 22 here. So then now you can work out this is 18 minus 36 plus 22, then this will give you 4. You see that already you have the same turning point. See, there are many ways. This is just to confirm. Imagine they say determine the coordinate, and maybe for 1 mark, maybe just instead of saying, then you say the coordinate, it's minus 3 and 4. Now already you're out of the game. So you need to check your workings, guys. You need to check your workings. And guys, let me be honest with you. In most of the exams, it's very rare for the examiner to ask you to sketch the graph. It's very rare for the examiner to ask you to sketch the graph. Most of the graphs or most of the questions in functions and graph, they give you a sketched graph. They give you a sketched graph. I'm not saying that they will not going to ask you to sketch it, but it's very rare in the final exam for you, for the examiner to ask you to sketch the graph. But you need to know how to sketch the graph. So now, in most of the cases, they sketch a graph for you and they ask you a question. Number 1, let me give you a hint, guys. Okay, before we move on, the issue of talking about the domain and the range. Domain and the range, ladies and gentlemen. Domain and the range. To know the domain and the range of your graph, especially for parabola, you must know your turning point. For example, look at this. If I know the graph has turned, maybe the turning point here is 2 and 4. And also I have the other one here. The graph, it's just an example. It's -3 and -8. Listen to me. To know the range here, remember the range, the domain means usually with this, we just use, it depends with where the graph is sketched, but if it's sketched on both sides, it's going to say X an element of real numbers, but it depends. But in terms of the range, we want to check where the graph actually exists. Look at this. What is the Y value here? The Y value is 4. But let's do this. If the Y value is 4, above 4, is this graph existing? The graph is not existing above 4. It's existing from 4 and below. So it means you're going to say, okay, from below it will be negative. It means the range here will be from negative infinity. We're going to say Y is an element from negative infinity to, what is the highest value there? 4 inclusive. Or you can just say it's any value of Y that is less than or equals to 4. You see, or if it's this, it means the graph exists from -8 and above. So it means the smallest value is negative. So we're going to say Y is an element from -8 to positive infinity. Or if you don't want to do this, remember infinity, we put an open bracket because you don't know what you're talking about. We don't know what is that infinity. So, or you can say it's any value of Y that is greater or equals to -8. I think we'll talk about this. I'm just addressing few marks, like 3 marks to get when we're dealing with hyperbola. I'm saying parabola. So now this is what I was like, the issue of domains and range. Then guys, again, let's talk about the issue of parabola when you are given a sketch graph, because I said usually in the exam they give you a graph which is being sketched and they ask you questions. How do you deal with such kind of right now? Like here, it's the case where you are given. How do we find the equation of the parabola? Finding the equation of the parabola. Finding the equation of the parabola when you are given a sketched graph. Finding the equation of the parabola given a graph that is being sketched. They sketch the graph for you and they say, determine the equation of a parabola. Listen to me very well. First of all, you need to check what you are given. If you are given 2x intercept, you know 2x intercept on the graph, and there is any other point on the graph, 2x intercept and any other point on the graph, always you must use this formula. Y equals to a into x minus x1 and x minus x2. So use this when we're given 2x intercept. You know x intercept on that graph, and there is any other point on the graph, then you can use a y equals to a into x minus 1 times x minus 2. But when you are given a turning point means you already know the P and the Q. You know the P and the Q, then you have any other point, you need to use this formula. Y equals to a into x minus p squared plus q. But how about you are just given any 3 points on the graph? Maybe you are given one x intercept, maybe with y intercept with another point. So it means you just have to use this one, ax squared plus bx plus c. But usually they prefer, or usually in the exam, they usually consider the first one and the second one. For example, let's say you are given this. This is just an example. There's a parabola. And then within this parabola, we are told, you know this, let's say it's -2 there, and there's 3. And there's a point, maybe it's the y-intercept, it's 0 and 6. And they say determine the equation of this. Already we have 2x intercept. We have this -2 and 0. We have 3 and 0, but still there's another point. What is that point? 0 and 6. So you see, this is just another point. But if you're not given other point, it means they have to give you the value of a. So already to get the equation, you're going to use this y equals to a into x minus x1, x minus x2. So you're going to say this is the x1, this is the x2, the x-intercept. So this will be a into x minus, what is the x1 minus 2? When you plug it, it will be plus 2, yeah? Then -3. Then you get the value of a by using this other point. Where there is y, you put 6. Where there is x, you put 0. So this will be 0 plus 2 and 0 minus 3. So this will give us 6 into 0 plus 2 is 2, 0 minus 3 is minus. So this will give us what? 6 equals to minus 6a. Then you divide by minus 6 both sides. So you see that the a becomes minus 1. And it's negative because it's the graph have a set face. So by looking at that, you're going to say y equals to a into x plus 2 and x minus 3. Then you substitute by a. The a is negative 1. So it's negative into a plus x plus 2 and x minus 3. Then you simplify your expression here. Simplifying your expression, what are you going to get? You will have y equals to minus, what is x and x? X squared minus 3x plus 2x minus 6. This will give us y equals to minus into x squared minus x minus 6. Then you multiply by negative, then y equals to minus x squared plus x plus 6. This is the equation. So you see that usually in the exam, you need to check what are you given actually. What are you actually given? And this is very, 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 very important. This is very, very, very important. So you can still get that. You can still get that. You can still get that. Remember, there are many ways to skin a cat. There are many ways to skin a cat. There are many ways to skin a cat. Like right now, if let's say since we are given the 2x-intercept here, we know this and we know this. We can be able, remember when we have 2x-intercept, we can be able to know the coordinate of the turning point here. The axis of symmetry, we can say to get the axis of symmetry, we can get x1 and x2, we divide them by 2. So what is the x1? The x1 is negative 2 plus 3 divided by 2. Then this will give us a value of half. And since you have half, you can still take these equations, okay, a into x minus p squared plus q. But this is also a long approach. So you can say, okay, you have the q is minus half, so you're going to have half there. Then plus, I'm the p is half, then you can still manipulate your expression to determine the value of a, p, and q simultaneous. But the best way is to use the one that I just said now. So in the exam, guys, usually, to be honest with you, in the exam, they give you a graph, then they ask you a question. So all the time, you need to check, what are you given? If you're given 2x-intercept, if they give you 2x-intercept, once they give you 2x-intercept, what do? You use the method that I'm actually explaining now. You use the method that I'm actually explaining now. X-intercept, you always use the method that I'm actually explaining now. Okay? Very, 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 very important, ladies and gentlemen. Okay, right. Let's continue. Remember, I said, okay. When you are given 2x-intercept, you use y equals to a into x minus x1 and x minus x2. And this will be used also in calculus cubic function. But for cubic, it means we add x minus x3. So when you are given a turning point, what do you use? Y equals to a into x minus p squared plus q. For example, let's say we are given a function here. And you know the turning point here. Let's just say this is 2 and 4. And you know, okay, fine, there's another point. So already here we have a turning point. What is the turning point? Turning point is 2 and 4. But there's still another point. And this point, even though it's not indicated, the graph is passing at the origin. So it means the other point is 0 and 0. And to get the equation means since we have the turning point, this is the p and the q. So we're going to say y equals to a into x minus p squared plus q. Then you get the answer. What is the p? The p, it's 2. And what is the q? The q, it's 4. Now you can get the a. How to get the a? We use this other point. Where there is y, you put 0. Where there is x, we put 0. Squared plus 4. Then we transpose this. This becomes 0 equals to 0 minus 2 squared. This is 4. It will give us 4a plus 4. Then we transpose this minus 4 equals to 4a. Then we divide by, then this gives us minus 1 because the graph is. So now we can write this. What is the a? The a here, the 8 negative, so it's going to be negative into x minus 2 squared plus 4. But if they wanted this to be in the form of y equals to ax, let's say they said we show that a is something, then it means you'll have to expand this to be in that form. There's no problem with that. So, but with this one, if they give you any 3 points, you have to use this one. But somewhere you have to use Martinez equation. I think I'll address this during the, like when I'm going to create a video. Right, then now let's video for parabola, because already I have created for hyperbola. Right, then now another one is the issue of an exponential. Guys, there's something good about an exponential that you need to know, guys, and I think I'll also create a video about the exponential. You need to be able to know the standard form of an exponential. Ladies and gentlemen, exponential has a standard form of, let me just write it down. Y equals to, this is for an exponential function, a times b to the power x plus p plus q. So you need to know the standard form of an exponential. And guys, very important, this b here should not be equals to 1 because it's an exponent. So now listen to me. When you are dealing with an exponential, you need to know the standard form of an exponential. I'm not talking about its inverse. Inverse, we'll talk about it later. Then you must be careful, guys. When you are dealing with an exponential, exponential has one asymptote. It has the horizontal asymptote only. Exponential has the horizontal asymptote, which means when you are dealing with an exponential, its horizontal asymptote is just about q, y equals to q. If they say write down the asymptote of an exponential, you always consider the q value, y equals to q, not horizontal. This is no longer an asymptote, okay? And again, when you are dealing with an exponential, if this b, remember I said b should not be 1. If this b, it's a value between 0 and 1. If the b is a number that is between 0 and 1, you must know that whatever the graph you're going to draw will increase from left to right. The graph will be an increasing function. No, I apologize. The graph should be a decreasing. The graph should be a decreasing function. But if the b is a number bigger than 1, your graph should always be increasing. And the good thing about an exponential is that you can still plot this by using a table method. For example, let's say you do this, y equals to 3 to the power of x. Someone might say, why are you saying this is an exponential while it's not? Look at this. Already you can rewrite this. You can say, let's identify this a values. The a here is 1. The a is 1. There is the a here. Then what is the p? The p is plus 0. So if I rearrange this number, this will be y equals to 3 to the power of x plus 0 plus 0. So you already see that if I were to analyze this, the value of a here will be 1, the value of p here will be 0, and the value of q here will be 0. But the asymptote, remember the asymptote for an exponential speak of y. So it means the asymptote will be y equals to 0 here. But if I rearrange, I say y equals to 3 to the power of x plus 1. You see the q now it's 1. So what is the asymptote here? The asymptote will be y equals to 1. I think I'll create a video of this one. I just want to remind you on some things. So it means it's very important to be able to know. Now, what is the b value? The b value, if we look at this, the b here, it's 3. And even then the b is 3. You see that the b is already bigger than 1. It means that if you sketch this graph, the graph will increase. But if, let's say you have y equals to 1 over 4 to the power of x, what is the b? Okay, the asymptote, remember the q is 0 here. So you're going to have y equals to 0 is the asymptote. So what is the b? The b is 1 over 4. 1 over 4 is a number that is between 0 and 1. So it shows that this graph will be decreasing. So it's very important to be able to understand how to deal with with what is this? With an exponential. And guys, when we are dealing with an exponential, there is the best way of sketching an exponential. You can use a table method. If they just say draw a graph or draw the graph of an exponential function, you can just use a table method. Let me show you how to do that. Imagine you have this. Remember, is this just, I'm just showing how, like the way you can get free marks actually. Free marks. Imagine you're going to say, okay, you have X and Y. You just tabulate this straightforward. All right, then you just generate three values of X. Let's say you use -1, 0, and 1. Then you just say, okay, right. If X is -1, so it means where there is X, you put -1. This will be 1/3. If X is 0, this will be 1. If X is 1, this will be 3. Okay, let us do another one. Let's say, okay, fine. Let's say we have this one, y equals to 1/4 to the power of X. We do the same. I wanted us to investigate the issue of increasing and decreasing of a function. Right. Right, let's do this. Let's say you have minus, this is X and Y, -1, 0, and 1. If you put -1 here, this will be 4. You'll get 4 because 1/4 is the same as 4 to the power minus X. So it will be 4. You put 0, it will be 1. You put 1, it will be 1/4. Look at this. Let's sketch the graph. Let's start with this side. If we sketch the graph for this one, this will be -1 here, 0 there, 1 is there. Let's say you have 1 and you have 2 there. I'll also do this one this side. Let's say this is the X and this is the Y. So -1, 0, and 1. So 1, 2, 3, and let's say 4 is somewhere there. Minus, okay, fine. Okay, 2, 3. Let me just say it's 3. Yeah. Right, look at this. First of all, what is the asymptote for this expression? Remember, I said asymptote has to do with Q. Q is 0 here. So it means the asymptote is Y equals to 0. So even this one asymptote is Y. So it means we can construct where it's Y equals 0. The Y equals 0 is on the X axis. So it means the graph must not touch this line. It must move parallel to this line. So this is the asymptote. We must first draw the asymptote. So it must move parallel to this line. So let's start. When X is -1, Y is 1/3. 1/3 is somewhere here. So it means we look at where they meet. So it's somewhere here. And we make a point. When X is 0, Y is 1. So this is the point. When X is 1, Y is 3. There's a point. So remember we said this means the line must move parallel to the asymptote. So it means the graph looks like this. So you see that since it looks like this, you see that the graph on its own is increasing. It's increasing because the value of B is bigger than 1. So it's very important to be able to know this. And these are easy marks to get, guys. Free marks to get, asymptote. Let's look at this one. When X is -1, when X is -1, what is the Y value? When X is -1, what is the Y value? Let me just use a different one. When X -1, Y is 4. 4 is somewhere here. So it means they meet somewhere here. Y is 4. When it's 0, it's 1. It's here. When it's 1, it's 1/4, somewhere there. Then you see that the graph, remember that the graph must move this side. It must not pass, must not. You see that the graph is decreasing. It's decreasing because the value of B it's between 0 and 1. So these are the things that you need to know. These are just easy marks, free marks to get, guys. Free marks to get, free marks to get, guys. And again, guys, if they say to you, now determine the inverse. Remember, if we say this is the F, its inverse will be this. So we know the inverse of an exponential, it's a logarithmic function. Logarithmic function. And guys, to sketch an inverse, it's easy because we always deal with what you call reflection about the line Y equals to X. Inverse, it means where there is X, we swap. X becomes Y and Y become X. So that's why if we say this is an F and we are asked to determine an inverse, it's straightforward. You just copy this, you just copy your table as it is, then you now swap the values of X and Y. So you swap the values of X and Y to sketch inverse. So I'm going to call this the inverse of the function. So you're going to do this. You write x here and you write y. So if it's the inverse, the values which was an x here now becomes 1, y. So it will be minus 1, 0, and 1. So this becomes y, this becomes x. So the x is 1 over 3, 1 and 3. So it means if they say to you, sketch the graph of an inverse, what do? You swap the values of x and y. Remember, you must always draw the line y equals to x. This is the line y equals to x. From your Cartesian plane, this is the line y equals to x. They want to see this. Let's now sketch the graph. When x is 1 over 3, because that's 1, when x is 1 over 3, what is the y value? The y value is negative 1. The y value is negative 1. And when x is 1, when x is 1, the y value is 0. It means the graph will pass here. When x is 3, the y value will be 1. So you just swap. Already you see the graph will move like this. The graph will move like this. You'll have something like this. The graph will not touch the y-axis, so it's going to move. You see that its asymptote will be this one. So because you are swapping the values of x and y. So it means this is the inverse of the graph. It's easier to sketch the inverse of a function. And this inverse of a function is actually called a logarithmic function. It's called a logarithmic function. So it's easy to sketch an exponential function, guys. It's easy to sketch an exponential function. But I will create a video for this, but I just want to show you that this is where you're supposed to just get free marks. Free marks. Now, how do we get the inverse of any function? How do we determine the inverse of a function? As a general way, number one, when we are determining the inverse of a function, I'll also do this. Number one, step number one, you need to swap x and y. You swap the values of x and y. And after swapping the values of x and y, you always make y the subject of the formula. The subject of the formula. Y the subject. For example, let's say you are having y equals to 2x plus 8. And let's call this g. And you are asked to determine the g inverse. G, remember, we have g inverse. This is the inverse, okay? G inverse. Remember, do not mix this with 1 over g of x. These are not the same thing. It's wrong, okay? All right. Then now, which means that, look at this. If you are determining the inverse, what do you do? It's easy. You just write the equation y equals to 2x plus 8. Step number one, you swap x and y. So where there is y you put x. Where there is x, you put y plus 8. Then you make y the subject of the formula. So it means you transpose 8. This side is going to be 8 minus x minus 8 equals to 2y. Then you divide by 8, by 2. This will be y equals to x minus 8 divided by 2. It's either you leave it like this as x minus 8 divided by 2. That will be the inverse. Or you divide everything by 2. Divide by 2. It means the equation is half x minus 4. So this is the inverse. Now, we want to know what is the inverse of an exponential. Obviously, the inverse of an exponential is a logarithm. So it means the only way this is the same as, so it means if we have y equals to 3 to the power of x. If this is f, its inverse, listen to me, will just be, actually, it will just be, you just put a log here, it will be log x base 3. Like this is the inverse of an exponential, which means the exponential, the inverse of a logarithm is also an exponential. But the question is, how do we get this? How can we show this? Why are we saying the inverse of an exponential? It's a log. Let me show you why are we saying that. Remember, I'm just addressing just topics where you're supposed to get free marks. Number one, let's do this. We're going to do this. We're going to apply, like we're going to say, okay, when we have y equals to 3 to the power of x, let's determine the inverse. We want to get the inverse. As a step number one, how to get the inverse? We swap the values of x and y. So it means where there is y, we put x, and where there is x, we put y. But we're not done. We need to make y the subject of the formula. But look at this. Our y that we need to solve is an exponent. And the only way to get rid of the exponent, to get rid of the power there, is to use log. So we're going to apply logs both sides. And once we apply logs, then the y will come down. So this will give us log x equals to y log 3. Then from here, this would be this would be so we want to make y the subject of the formula. So it means we divide both sides by the log of 3. Let's divide by log of 3 and divide by the log of 3. So this will be y equals to log x over log 3. So according to the law of logarithm, the denominator will now become the base. And so this is the same as log of x with the base of 3. You see, this and this is the same. So usually if they say write down the inverse for this one, for example, for this one, obviously you can just say the inverse is just log x base 4. But if they say show all your workings, that's where you have to do. If they this is just free marks to get, guys. Free marks to get. Always, to get the inverse, you need to do that. Practice makes perfect, guys. Practice makes perfect. Very, very, very important. And let me also talk about the issue of determining the domain and the range of an exponential. Okay, as I was saying that, from the exponential function, we can be able to determine the range and the domain of a function. Remember, with an exponential function, we said if the function is actually increasing, the b here is bigger than 1, then we can be able to tell what is the asymptote. The asymptote of an exponential, we know it's y equals to 0 here, because of the q is 0. So which means that the graph will not going to touch this line. This is y equals to 0. So now, when we have an exponential function, we can be able to know what is the domain, and what is the range of a function. Remember, we said the domain is a set of y values. No, I'm saying set of x values where the graph exists. So what does this mean? It means that within this graph, we can see that any value of x, if you use any value of x on the number on the x-axis, will actually give us the value of y. Any value of x will give us the value of y. So which means there are no restrictions on the domain when we're dealing with exponential, which means the domain, it says x is an element of a real number, which means we can use numbers from negative infinity to positive infinity. But however, when we want to do the range of the graph, range depends on y. So what is the y value here on the x-axis? The y value is 0. You can see that any value less than 0, the graph is not existing. The graph exists from 0 and upwards, but excluding 0 up until infinity. So this is the range. So it means we can say the range of y is any value of y that is bigger than 0, where y is an element of real number, or we can say y is an element from 0 up until infinity. It means it exists from 0 up until infinity. So it depends on the what? On the asymptote of a function. And now, if this depends on the asymptote of the function, remember this is the f. What if we want to know the domain or the inverse? I'm saying the domain and the range of the inverse. What could be the range of the inverse? As I said, this is log x base 3. Then let me explain this so that you can understand. If you are able to determine the range and the domain of the function of f, it's easier to know the domain and the range of the inverse, because these are reflected about the line y equals to x. So what does it mean? It means, I want you guys to listen to me. Remember, when we are determining the inverse of the function, what do? We swap x and y. So which means same applies. If we swap x and y, is the same as when you swap the domain and the range. So what does it mean? It means the domain of the function, it will be the range of its inverse. So it means the range of the inverse, we just change the x now becomes y, which means we're going to say y is an element of a real number. We're just changing this one. Then it means the domain of the inverse will be the range of the function. It means we're going to say x should be bigger than 0. Or we can say x is an element, I mean, it's an alternative. We can just say, or x is an element from 0 to infinity. Because if we were to draw the inverse of this graph, its inverse would be something like this. So you can easily see that the inverse of this graph, its domain ranges from 0 upwards. So it means it's any number from 0 to infinity. Whereas the range, we can use n. You see, so I'm saying once you know when you know the information of the function, then it's easier to be able to know the domain and the range of its inverse. You just swap. If the f had a domain, like the domain of f will be the range of the inverse. So it's very, 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 very important to know that. I think I'll also address the issue of exponential later on in a video, but I just wanted to show you that these are the things that you need to know in order to get good marks in functions and graphs. Then another one is the issue of a straight line, ladies and gentlemen. The issue of the straight line. You need to be able to deal with a straight line. Remember, when you are dealing with a straight line, you need to be able to know the standard form of a straight line. Usually, we went through these also in analytical geometry, where we're determining the equation of a straight line. And how do you determine the equation of a straight line, ladies and gentlemen? We use it as a standard form of y equals to mx plus c. So let's write this down. So a straight line has a standard form of y equals to mx plus c, or we use y minus y1 equals to m into x minus x1, whereby the m here, it represents the slope or the gradient. And we know that if the gradient is positive, means the line is increasing. And how do we incorporate this straight lines with parabola? Like before that, you need to also be able to sketch the steps of sketching a function, straight line. Obviously, with a straight line, you just have to get the x-intercept and the y-intercept. So we know x-intercept, we let y to be 0, and y-intercept, we let x to be 0. I mean, look at this. Consider we have something like this. There is a function here, it's a parabola with a set face, and there is just a line. Let's say there's a straight line passing through. We know this point here. Let's say the coordinate of it's 2 and 4. Just an example, this one here, it's 0 and 1. Then we are told to determine the equation of the line. So obviously, if we have 2 points, remember that we have 0 and 1, and also we have 2 and 4. To determine the equation of the line between 2 points, straightforward, we get the gradient, changing y over changing x, y2 minus y1, x2 minus x1. So we can just choose any x1, y1, x2, y2. So we're going to have 4 minus 1 over 2 minus 0, which will just give us a gradient of 3 over 2. So our equation will be y equals to mx plus c. And what is the m? The m is 3 over 2. So we're going to have 3 over 2x plus c. And to get the c, we can either use the first point or the second point to get. So the y value, if we use the first one, what will be the y value? It's 1. Then the x value will be 0 plus c. So the c becomes 1. So therefore, what is the equation? The equation of the line is 3 over 2x plus 1. So you can easily see that when we have 2 points, it's easier to determine the equation of the line. But how about if we just want, let's say, for example, on the same curve, this time around, we're given a tangent. There's a tangent that is actually passing through the curve once. So you want to know what is the equation. Let's say the coordinate here is around, let's say it's around 1 and 1. It's just an example, around 1 and 1. So we want to know the equation of this. Obviously, to know the equation of this, we need to know the equation of this function. So let's just say the parabola is given by minus x squared plus 3x, just an example, plus 3x minus 2. So already what you do, because we want to find the equation of a tangent at a point. And remember, a tangent at a point, we only have one point there, which is 1 and 1. So we cannot calculate the gradient with 1 point. So we have to use calculus. Why? Because calculus is teaching us how to determine the gradient at a point. So when we make f prime x, we're actually talking about the gradient at a point. This is a gradient function at a point. So we're doing this to determine the gradient at a point. So we have to make f prime x. We differentiate our expression. We're going to have minus x squared. Okay, I believe you know how to differentiate. So you're going to have minus 2x squared minus 2x, apologize, minus 2x plus 3. Then to get the gradient means where there is x, we substitute by 1. This is the x. So you're going to have 1 plus 3. Then the gradient will be 1. It's positive. So now we can be able to find the equation y equals to mx plus c. Now the gradient is 1. We substitute, we're going to have x plus c. To get the c, it means you can use that point again. Where there is y, because it's only 1 point there. Where there's y, we put 1. Where there's x, we put 1. So the c value will be 0. So it means the equation is y equals to x. This equation is y equals to x. And it does make sense because this is the line y equals to x. So you see, you can be able to determine the equation of a tangent in this. Sometimes they can give you an angle of inclination, like in functions and graph. They can just tell you, okay, there is a line that is touched the curve once and forms an angle of inclination of, let's say, 112. So they know when they give an angle of inclination, you will be able to use to calculate the gradient by say gradient is equals to tan theta from the Euclidean analytical geometry. So the angle of inclination is 112. So it will help us to calculate the gradient. So we can be able to get the gradient function. So remember, guys, these are some of the things that you need to be able to know when you are dealing with functions and graphs. So finding the equation of a straight line, it's one of the easiest. But if you're given 1 point, the best way is to use calculus. Calculus will enable you to determine the gradient at a point. So once you differentiate a function, it's now giving you a gradient function. So it's an equation of a function actually, which depends on the value of x. So it means if you plug any value of x, it will actually give you the gradient. So that is what you need to know. Right, guys, these are one of the topics, like in terms of what I'm actually addressing to you. Once you go through what I just said now, you will be good to go. Right, the other one is the issue of, however, I'll be able to cover each topic, but for now, I just want to address how to actually can get good marks from there. Right, another one is the issue of reflections, ladies and gentlemen. We have what you call reflection about the x-axis. When one is reflecting a point about the x-axis, what does it mean? Reflection about the x-axis, it means within the coordinate of x and y. Reflection about the x-axis means x does not change. What changes is the y. This is called reflection about the x-axis, because if we just have a Cartesian plane of x and y, and we just given a point here, let's say this is a point of x and y. About the x-axis means this point must pass through the x-axis. So it means you see that the x did not change. What just changes the y. So this is a reflection about the x-axis. Then also have reflection about the y-axis. Y-axis, what does it mean with this? It means reflection about the y-axis. The y will not change. What will change is the x. If x is positive, now becoming negative, but the y remains the same. So reflection about x, x does not change. Reflection about y, y does not change. What changes is the x. So again, reflection about the line y equals to x. This has to do with the inverse. reflection about the line when y equals to x means when you have x and y, then the x becomes y and the y becomes x. So you swap the values of x and y. This is what we use when you're determining the inverse actually. Then how about the reflection about the line y equals to x? Reflection about the line y equals to x means when you have x and y, both x and y swap. So x becomes y and y becomes x, but both becomes negative. So it means they swap, but the sign changes in both of them. Remember from our Cartesian plane, where is the line y equals to x? The line y equals to x is this one. This is y equals to x. And this other one, the other one, this is y equals to minus x. So you see that when you're dealing with reflection about the negative x, it means if you have a point, let's say you have a point somewhere, then you have to reflect. It means whatever, let's say if it was positive, they will still swap, but the sign will be both negative. So they swap the values of x and y, they swap, but they change the sign, both of them. So this is what you need to know when you are dealing with transformations, reflections. Then we also have that one where we said you are translating or you are shifting a point. You're shifting a point, not necessarily a graph. When we are shifting a point, or even a graph, yes, a graph to the left. And what does it mean? It means now, when we are dealing with shifting, this is what you're going to do. When you are shifting to the right or to the left, you always affect the x values. But when you're moving up and down, you're always affecting y values. So which means if I write a function like this, f of x minus a. So since here there is a minus inside the function of x, inside the function of x, there's a minus. So this is telling us that the function will shift a unit to the right. So the function will shift a unit to the right because of the minus. But if we have f of x plus a, then it means the graph will shift inside the function. The graph will shift a units to the left. So you need to understand this. To the left in a function, we see by a plus. To the right in a function, we see by a minus. But as a coordinate, something that is shifting to the right, as a coordinate, something that is shifting to the right increases the value of x. So if we say we are shifting a units to the right in a coordinate, as a coordinate, not as a function, but as a coordinate, we need to increase the x by a. But a function that is shifting to the left on a function, we see by a plus. But in a coordinate, a point that is shifting to the left, it means the value of a has to decrease by the shifting value. Then the y does not change because we are not affecting the y. So for example, let's say we are given a turning point, and these are exam typical questions. Right? Let's say we are given a turning point of f. Okay, before I talk about that, it's fine. Let's say we are given a turning point of f. We're told that the coordinate of the turning point of f is 2 and 8. But this time around, we want to get the coordinate of the turning point of f of x minus 3. It's a different case now. This was just for f of x, the TP. Now we want for f of x minus 3. Already, let's describe this. This shows that the f will shift 3 units right. So it means we know if you're shifting 3 units to the right, this will, in a coordinate, it will increase the value of x. So it will be 2 plus 3. The value of y will not change. So which means that the turning point of the function now will be 5 and 8. Because if we were to say, okay, let me just say it's the Cartesian plane, there's my turning point is 2 and 8. So you see that the value of x is 2, the value of y is 8. But I want this to shift this point 3 units to the right, so it's going to be 1 unit, 2 units and 3 units. So it's going to, you see that when I'm moving to the right, now it will increase to 3, to 4, and to 5. You see that the value is increased by 3. Now it has a coordinate of 5. So it means in a function, when we say a function is shifting to the right, in a function we see by a minus. This is to the right. This is inside the function with x. This is left. But as a coordinate, right has to increase the x. Left has to decrease the x. But if you say f of x minus a, you see this is no longer inside the function of x. So it means now this is now shifting downwards. It's affecting the y value, shifting downwards. This is shifting upwards because it's no longer inside the function of x, it's outside. For example, if we say f of x minus 3 plus 1, let's describe this. This graph will shift 3 units right and 1 unit upwards. 3 units right and 1 unit upwards. So what does it mean? It means in a coordinate, when we have x and y, to the right will increase the value of x, so we're going to increase the value of x by 3. Upwards, obviously, it will increase the value of y, so it's y plus 1. So with upwards, it's just plus y, plus then what is the minus. So which means with the same point of 2 and 8, if you are moving to the right, so it means the x will increase by 3, this will be 5. Upwards means now it will increase by 1, it will be 9. So the new coordinate will be 5 and 9. So this also applies in intrigue trigonometry. It's not about the here only. And there is also that other part where you have sketched, they've given you a graph, they say for which values of x is f bigger than g, where they're both increasing. We'll talk about that when I'm going to create the video for parabola. And these are exam typical question. Reflection about the x-axis, x does not change. What changes is the y. Reflection about y-axis, y does not change. What changes is the x. For example, they can give you an expression. Okay, let's say you're given an expression like this. These are just free marks, guys. Just free marks. Okay, they can give you something like this. They say, okay, fine. Since we're given a function, let's call our function f of x. Let's say you're having y equals to 4 to the power of x. And they say, write down the new equation. Write down the new equation of h, which resulted after reflecting this graph. We want to reflect this graph about the x-axis. What does it mean? So it means about the x-axis, when we have y equals to 4 over x. About the x-axis, what they say? The x will not change. What will change is the y. So if the y is positive, now it becomes negative. But we cannot leave the equation with the minus like this. Now we need to multiply both by negative. So this will be, when you multiply both by negative, the equation will be y equals to minus 4 to the power of x. So this is a reflection about the x-axis. But if we were to do with the same reflection about the y-axis, means the y must not change now. What is changed is the x, which means if x, since the x is positive, now you're going to change it to be negative. So it's just straightforward. And what is this? This is the same as we either leave it like this or we write it as 4, 1 over x, 4 to the power of x. Because we know 1 over 4 is the same as 4 to the power negative 1. And if you multiply this by x, we can multiply, so it will still give us the same thing. But if we do this, we say, let's say we have something like this. So you need to be able to describe the transformation. And these are exam typical questions, guys. So let's say we have, okay, we want to describe what could have happened from the original function if something like this happens. I want to give you an example. Okay, let's say we had something like this. Let's say we have from the let's call this from the y equals to 4 to the power of x. Now we have a g. The g is now like something like this: 4 to the power of x plus 1 minus 3. You see that there's an additional values here they've added. You see there's a different, there was no 1 here and there was no 3. What can you say? Let's describe what has happened. Remember, we know exponential has only one asymptote, and this is the p. We have a p and we have a q. These are just the shifting value. So it means because there's a plus here on x, so it means the graph will shift 1 unit to the left because there's a plus there, and also shift 3 units downwards. So it means in any point of f, if we know any value of x on the f, if we wanted to change it to become g, what do we do? Because it's shifting to the left, it means we have to reduce the value of x by 1. And downwards, you have to reduce the value of y by 3. So this is what we'll be having. So it means if we have, let's say we have a point there on this graph, there's 1 point, is 0 and 1. So you see that the 0 and 1 now will now become this. It will be 0 and minus 1 and 1 minus 3. So these values will now become minus 1 and minus 2 because it's now shifting downwards. Okay? Right. Then now, actually, I'm just showing you actually what did you do in order to get good, like free marks actually. Translations are very important. Transformation actually. Then there is this other part where we have there's some instance where they talk about enlargements, but I we'll talk about that later. So right, let's talk about what are the conditions that makes a graph to be a function or not. And this is grade 12. Remember we said a function, if we say we have a function can either be 1-to-1 or many-to-1. It's a function. But something that is not a function, it's either it's 1-to-many or many-to-many. But now the question is, how do you able to check whether a graph is a function or not? Imagine when we are given a parabola like this. Let's call this f of x with the turning point of 0 and 0. To check whether a graph is a function or not, I'm not talking about 1-to-1 or many. To check whether a graph is a function or not, we always use vertical line test. And I think I've taught you this, but just to remind you, with the vertical line test, it says if you draw vertical lines, if you draw or you construct vertical lines on the graph, and you find that every line that you have drawn, any vertical line that you've drawn, it touches the curve once. If it touches the curve once, it means it's a function. It is a function. Why it is a function? Because the vertical line touch the graph once. The vertical line touch the graph once. And now, since we are now aware that this is a function, the question is, what type of a function is this? Is this a 1-to-1 or is this a many-to-1? To do that, we have to use a horizontal line. Vertical line is to test whether a graph is a function or not. But horizontal line is to check if that graph, because it's a function, what kind of a graph is it 1-to-1 or many-to-1? If the vertical line touches the graph more than once, it means it's not a 1-to-1, it's a many to 1. It's true because look, if we look at this here, if we look at the value of x here, and this value of x this side, you see that there are two values of x. There are two values of x, x1 and x2. Let's say x1 and x2, which can give us one answer. Two values of x can give us one answer. You see that they're moving from many to 1. So which means that it is a function, but this type of a function is actually a many to 1. But if the horizontal line touches the curve once, so it's going to be a 1 to 1 because already we know it's a function. Now the question is, what if we want to get the inverse of this function? Obviously, the inverse of the function will be reflected about the line y equals to x. So it means the inverse of the function will be something like this. Remember, this is the original function. Its inverse will look like this. So this is the inverse. And why am I saying it's the inverse? Remember, we said when we're determining the inverse of a function, what do? We swap the values of x and y. So this become x, this become y, and we make y the subject. So we have to put the root sign. And to do that, we have to allow plus and minus. So it means the value of y here, it's plus or minus the root of x, which means the upper part, this upper part is the one which is the positive root x, and this one is the negative root x. But now if we draw, remember this is the inverse. If we draw a vertical line on the inverse, drawing a vertical line on the inverse, it touches the curve once, more than once. So it touches the curve here and there. So it is not a function. It's a non-function. Why? Because the vertical line touches the curve more than once. And why? What is the reason of this? Look, we have one value of x will give us two answers. It will give us this one. You see that we are moving from one to many. And once we have one to many, then already it shows that this is not a function. And sometimes in the exam, they can say, what can we do from the original function? What can we restrict in terms of the domain? Remember, the domain of this parabola, it's x an element of real numbers, because we can use negative values and positive values to give us the answer. So the question might say, what can we do in the original function in order, what can we restrict in terms of the domain for its inverse to be a function? We have seen that it's not a function, but what can we do from the parabola to ensure that its inverse is a function? It's straightforward. And these guys are exam typical questions. So it means from the graph, I'm actually addressing things that are like, they're easy to get. From the graph, look at this. Remember, this is the original function. Is the y equals to x squared. You see that from the original function, we can do this. We can either restrict any value that is less than 0. So it means we can restrict, remember this is where x is negative. So we can restrict any value less than 0, or we restrict any value bigger than 0. So it means, what does it mean? We can do away with one part of the function. So let's say we do away with this part. And this is exam typical question. I apologize guys. We do away with one part. So remember we had 2. So we do away with this other part. So you see that when we do away with this other part, when we do the inverse will be this one only, this part only. So it means the inverse of the graph, remember this will be the f. The inverse of the graph will be this, will be where we have the root of x, the plus root of x. And in that case, you see that when we draw a vertical line on this only, it will now become a function because it touches the line, the curve once. So it's either we restrict any value bigger than less than 0, or we restrict any value bigger than 0. So if we are restricting any value bigger than 0, it means we will remain with this other part. So we'll remain with this other part here. We'll remain with this. And once we remain with this, it means when you do the inverse will be this one. This other part. The y equals to negative root x. So you see that by so doing, this will give us an inverse. Remember about the line y equals to x. So this is what you need to know, guys, when you are dealing with functions and graphs. Very important. It has lot and lot of marks. I think I will also create a video to remind you more about functions, whether it's a function or not. Vertical line test and horizontal line test. Very important, ladies and gentlemen. That's why in the exam, they can say to you, okay, before we move on, they can say to you that you are given a function. You are given a function. So you need to make sure that you check your things very well, because sometimes examiner can give you conditions, then you end up falling outside of that condition. Already it means you're not going to get full marks. Let's say with the same function, we have this, we're given this. They told us that g of x is x squared. Then there's a condition, they say the x should be either be greater or equal to 0. You see that because of this, they say, yes, parabola, even if you use a table method, you're still gonna get the function. From, let's say, x and y, -1, 0, and 1. But now, it says, when you sketch this graph, if it sketch the graph, consider only positive values. So it means you're not gonna talk about negative values. So it means your graph will only consider this part only. So you need to be careful when you are determining your equation. So this is y equals to x because of this. If you show these other ones, then it will be wrong because you were given a condition. There was a condition provided there. And if they say, is this a function? And you say, yes, it's a function. Reason, the vertical line touches the curve once, or it's a one-to-one, because when you draw a horizontal line touches the curve once, so it's a one-to-one function. Why? Any value, one value of x will give me one value of y. So every element in the domain will give me every element in the one element in the range. So it's a one-to-one. So and they say draw the inverse, you have to always show this line, the line y equals to x. It's very important. Very, very, very important, guys. Then the other one is the issue of differential calculus. Remember, differential calculus, it goes everywhere. Like in functions, you can use it anywhere. Right. Finding the equation of a tangent, I think I have addressed it when we determine the equation of a straight line. I think I've addressed that. Let's now determining the maximum of the minimum distance between the two graphs. And this is exam typical questions, guys. It's very, 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 very important to be able to understand what I'm actually explaining here. Consider a function. Let's say you are given a curve, and it's also applicable to, like in calculus under optimization, you can still have something like this. Let's say sometimes they give you a function. Let's say they give you a parabola. Just an example. Within a parabola, they say there's a straight line. Then they say there is a point here. Let's call it point A. And this point is parallel to the y-axis. Let's say this point B. It's on F. Then they say determine the maximum distance between A and B. What do? Let's say this is the F, this is the G. Always, when you calculate the maximum distance between two graphs, you always take the top graph. You take the graph that is at the top, you subtract the graph that is at the bottom. So what is the top graph? Top graph is the F. The bottom graph is the G. Then you have your equation in the form of x and y, and in terms of x. Then to determine the maximum length, if this is our equation, it's in a quadratic form, ax squared plus bx plus c. We can use axis of symmetry minus b over 2a. Or otherwise, you have to know that for maximum or for minimum, you differentiate your function with respect to the variable that of interest, then equate to 0, solve for x. Then the value of x that you're going to get, you substitute into this equation that will give you the length of AB. We'll talk about this, ladies and gentlemen. Top graph minus the bottom. We usually use this to determine the length between 2 points. And it's also applicable to calculus, optimization. Free marks, guys. Free marks to get. Free marks to get only when you practice. So you can see that I've taken more time on functions and graph because function graph, it's one of the topics that has a lot and lot of marks. Functions and graph, it's one of the topics that has lot and lot of marks. All right, then now the other one is the issue of financial maths. Remember, I wanted to first address those that have a lot of marks. But actually, financial maths comes after calculus. It comes after calculus. Calculus has more marks than financial maths because usually it comes in 3 questions. It comes in 3 questions, and this is one of the easiest actually. It comes in 3 questions. Now, in the issue of optimization, this part, I'll talk about, let me talk about differential calculus. In the issue of optimization, I've already created a video for optimization and the rate of change. So I will encourage you to go and watch this video. Then you like, yeah, you watch the video, but I'm still going to address it, but you need to watch the video because this is one of the easiest questions actually. This is actually called the application to calculus. It's application to calculus. We're using calculus to do the application, to solve problems. And I apologize, guys. Are you following? Right. But now, if like for simplicity, because I've explained that what is this? Calculus has a lot of marks. We can either go to finance, then we'll come back to calculus. So it means maybe calculus, I can create a video where I can address differential calculus separate with probability and fundamental accounting principle. So it means whatever I've explained earlier to the part 1, then the part 2 will be covered in this other one, but I'll see what I can do. All right, let's just go back to the financial maths. Right, in terms of finance, guys, and guys, let me say this again. Finance is one of, how can I say it? It's one of the easy as ABC. So you need to make sure that you spend more time on this. Number 1, you need to familiarize yourself with the way depreciation and appreciation. We know depreciation has to do with the loss of value. When an asset or something loses value, we say it's depreciating. So it means you only use this depreciation only when the formula you have to use a minus. Once you read the question, they say depreciation, you have to know that you're using a minus formula. So appreciation means you're using a plus formula all the time. It means the gain of value. Then again, ladies and gentlemen, you need to be able to differentiate between a simple interest formula versus compound interest. All right, with the simple interest, the formula it's A equals to P into 1 plus I times M, with A equals to P into 1 minus I times N. So that means the minus, we use it when we're dealing with depreciation. The plus, we use it when we're dealing with appreciation, the gain of value. For example, if one is doing investments, obviously you have to use a plus. Okay, but I want to tell you something about the simple interest formula. These ones they give you, even the compound, there are 2 formulas for compound. We have A equals to P into 1 plus I to the power of N, and A equals to P into 1 minus I to the power of N. But this one for a simple, for the minus, is called a straight line depreciation method. Straight line depreciation method. Remember, the P is the present value or the principal amount. The P we can be regarded as the money borrowed or invested in terms of like if one is investing or borrowing money or a principal amount. The A is the future value, but in most of the case, when you use a plus, the A should be bigger than P. When you're using a minus, the A should be less than P. Then how about this other one with the minus on this side? it's also having a name. It's called a reducing balance method. If they say on a reducing balance, they're referring to this formula. Or diminishing balance. Let me be honest with you. Most of the questions in the exams, we rarely use, or they rarely use, simple interest formula. I'm not saying that they're not using it, but like, let me be honest with you. You only use simple interest formula if they mention something about simple interest. If they do not say anything about simple interest or straight line, whatever, do not use simple interest formula. Always use compound interest. Because this is what actually most learners do. If you read the question and they do not say anything about simple interest basis or straight line, they do not even play around the simple interest formulas. And remember, the only thing with finance is that once you use a wrong formula, you are out of the game. So make sure you go through this. Then another thing is the issue of the compounding periods and interest rate. Remember, once you read the question, they say compounding something, you know you're dealing with the compound interest. So we have things like compounded monthly, and this is very important, monthly, quarterly, weekly, daily, half yearly, or semi-annually, and annually. Unfortunately, we do not have hourly. So these things compounded, once they say compound, you know you're using compound interest. These things affect the interest rate and affect the number of years. For example, let's say the interest rate is given as 7% per annum. Then the number of years, it says 5. If they say it's per annum compounded monthly, you have to say, in a year, how many months are in a year? 12. So it means the frequency is 12. How many quarters are in a year? 4. How many weeks are in a year? On average is 52. How many days are in a year? Is 365 on average. Half yearly, how many halves are in a year? 2. The annual is just 1. So which means when you are dealing with the interest rate, if the interest rate is, let's say, 0.07, because it's 7%. So if it's compounded monthly, you divide it by 12. And you multiply the number of years by 12. The number of years by 12. But if it's compounded quarterly, you divide the interest by 4. You multiply the number of years by 4. Number of years by 4 to be in quarters. If the interest it's weekly, you divide the interest by 52. And you multiply the number of years by 52 to change everything into weeks. Same applies daily, 365 multiplied by 365. Half yearly, you divide the interest by 2, multiply the number of years by 2. Annually, it means it will do not change. So this is one of the things that you need to be able to know when you are dealing with financial maths. But please, guys, remember this. Do not play around the simple interest unless you are told to do so. Want to take a wrong formula? Already you are out of the game. So make sure you check what you are doing, ladies and gentlemen. For example, if they say, how long will it take for the investment to double? How long will it take for the investment to double? How long in years? Is this an example? How long will it take? And they like this question. How long will it take? How long in years will it take an investment to double at, let's say, 7% per annum? You see, how long in years? It means you want the end. Will it take for this investment to do, you see, you're investing? Obviously, if you're doing investment, you're not going to use a minus formula. It means it needs a plus formula. For the investment to do what? To double. What does this mean? This is one of the easiest. It's like, okay, let's say you have A, P, the I, and the N. Already, they did not say anything about compounded monthly or whatever. They just say 7% per annum. So we just say, take this 7 and say 7 out of 100, which is 0.07. We are not dividing anything with, we are not dividing with 12 or anything because they did not say anything about compounded. So we just want this N. But we don't know how much was invested. And like, for example, it's straightforward. We just say, let's let P to be X. So if you want this to be doubled, it means in the future, remember this is the future accumulated value. It means to be 2x. We want it to double. Remember, you can use any amounts. You can even come up with any amount. It's not about x only. Can you say if I use 1,000, I want my investment to double, it means now it will be 2,000. The answers will be the same. The answers will be the same. Now, here's the trick part. What did I say? I said, since they did not say anything about simple interest, we use compound interest. They did not say anything about simple interest, so we use compound interest. Why compound? Usually most of the investment, actually simple interest are usually done by, like, this Machonisa and these small enterprises, but usually in most of the banks or whatever, they usually use compound interest. So that's why we're going to have A equals to P into 1 plus I to the N. We're using a plus because we're dealing with investments. Not necessarily in terms of, but they're not like, it shows that whatever we're doing, it has to increase. What is the A? You can use any amount. You have 2 rand, you want it to double, it means it will be 4. Can you come up with any amount? So it means here is 2x, there is the x. What is the interest? Is 0.07. We do not divide by anything, 12 or anything, because they did not say anything about that. So this will be, we can divide both by x. So this will give us 2 into, let's add this. This is 1.07 to the power of n. We want the n. Remember, it's a power. We have to use logs. So you're going to have log 2. By applying log, it means the n will come down, like what I said, 1.07. Then let's divide there by the log of 1.07, and we divide there by the log of 1.07. Then this will divide and get the log. Unfortunately, I don't have a calculator with me, but we can be able to know the number of years that we take for this investment to double. Remember, guys, you do not play around simple interest if they do not say anything. So make sure you know your formulas very well. Make sure you know your formulas very well. And the other thing, ladies and gentlemen, is the issue of being able to master or to know the formula to convert from nominal to effective and from effective to nominal. I will create a video for these things, but I just want to remind you, this is one of the easiest topic in maths paper, like algebra actually. Yeah, you need to remember this formula, guys. Then they're not going to give you this formula, which says the I effective, equals to 1 plus I norm. Norm is for the nominal. I norm, over m to the power of m minus 1. So it's I effective into 1 plus the nominal divide by m, everything to the power of m minus 1. Listen to me very well. If you want to see, remember, this formula, you must know it. You must know the formula. We use it to convert from nominal to effective or from effective to nominal. And now, let me tell you, how do you see even interest rate? It's nominal. Any interest rate that is nominal, it's always compounded. So for example, if they say, let's say you're given this. Let's say you're given this. If they say 7% per annum, comma, and they say compounded, let's say compounded monthly. Already, by looking at this, once they give you an interest rate, and this interest rate, after they said it is compounded monthly, quarterly, you must know this is already the nominal interest rate. So this compounding period is actually the M. So it means monthly, it means we use an M of 12. Weekly, we use an M. So it means already from this, we know this is the nominal, we can get the effective. So it means to do that, you're going to say, write the formula and say, okay, fine. I effective equals to 1 plus I norm over the m to the power of m minus 1. And this question, you need to know it, guys. All right, the I effective, what is the nominal? The nominal is 7%, which is compound. So it's 7%, 7 over 100, this is 0.07 over. Because now it's compounded monthly, our frequency is 12 to the power of 12 minus 1. Please, always, when you're calculating the interest rate, you have to round your numbers to 4 decimal places. 4 decimal places, because when you multiply them by 100, they will be into decimal places. So this will be, I don't have a calculator with me, 0.07 divided by 12 plus 1, everything to the power of 12, if I'm not mistaken, to the power of 12, we can still confirm that. Then minus 1, this will give us 0. We must round to 4 decimal places, 0.0723. Then when you round to 4 decimal places, remember we need to multiply this by 100. It will give you your answer in 2 decimal places. This will be 7.23%. This is what you need to know. And guys, remember, sometimes they can give you an effective and they want you to calculate the nominal. They can give you an effective and they want you to calculate. These are the formulas that you need to master because you will not be given in the exam. So if it was compounded weekly, the M will be 52. Daily, the M will be 365. Half yearly, the M will be 2. So it depends with the question. For example, if they say calculate the annual, the annual interest rate, like the effective interest is actually calculated annually. Calculate the annual effective interest rate with a nominal, okay, with on what? Okay, on, let's say on 9% per annum compounded quarterly. You see that once they say you know it is a nominal. So what are we going to do? It means now it's an opposite. Now we're not going to do what we have. Remember, this time around, what are we given? We are given the nominal. No. What? Okay, no. I want to calculate the nominal when we have the effective. I apologize, guys. Because it's still going to be the same thing. Yeah. So now, let's say it says calculate the effective when the calculate the nominal when the effective is 9%. Yes. We want to calculate the nominal interest rate given an effective. So it means now we have this. So we have I effective 1 plus I normal. Let me just write the over m minus 1. Let's substitute what we know. The effective we know that it's 9 over 100. 9 over 100 is how much? 0.09. Now we want the effective. It's I over what is the m? The m is, because it's quarterly. Oh, did not. Okay, let's say nominal, which is compounded quarterly. Let's say the m is 4 here to the power of 4 minus 1. So we're going to transpose minus 1 this side. This will give us 1 plus 0.2 is 1.09 equals to 1 plus I over 4 to the power of 4. Now we're going to do this. We want to get the I. You see now there's a power here. We no longer use the logs here. Now it means you have to use the exponents part. So to do that, this is one of the easiest actually. We do this. To avoid transposing, remember we can make 4 over 1 then multiply by 1 over 4. So to avoid that, it means we do this. Let me show you the proper way. So it means now we'll do this. We'll say, okay, fine. Since this one is 1.09, then you're going to have 1 plus I over 4 to the power 4. What you do, you just put the root sign here and the root sign here. So since there's a 4 here, we just make the fourth root. And once we have made the fourth root, means we must also do it this side. So it will be the fourth root of 1.09, which is the same as 1.09 to the power 1 over 4. So the same thing. So you can just calculate the fourth root of that. I don't have a calculator with me. Okay, then now I think this will give us, if I'm not mistaken, 0.2725. You'll confirm. Then this one will make this to be remain with 1 plus I over 4. Then we subtract this. Okay, just a minute. To the power. Okay. Yeah, okay, my apology, guys. It's not the answer, this one. Okay. You see that you need to confirm your work. Right, this gives us 1 point, because I don't have a calculator, 1.0218. So we transpose 1 this side. This will give, we subtract by 1 will be 0.0218. We're gonna remain with I over 4. This over 1, we cross multiply. Minus 1. So 0.0218 by 4, it will be 0.0872. Then we multiply this by 100. So obviously with 100 will be 8.72. So this is now the denominator. So you need to be able to work out in both cases. Okay, let's now move on, guys. Right, the other one is the issue of a sinking fund. I think this one I have to address it. Sinking fund. How do we determine the sinking funds? A sinking fund is the funds that is needed to replace the value of an asset. Actually, let's do this. Sorry, apologize, guys. To calculate sinking funds, do this. We take the appreciated value from a compound and we minus the book value. The value after depreciation. All right, now, what is the formula? Appreciated value means is this one of A equals to P into 1 plus I to the N. So we take P into 1 plus I to the power of N. We minus the one for the is going to be P into 1 minus I to the N. Whatever the difference remaining with it will be the sinking fund. Why am I saying this? Let me give you an example. Let's say you bought a machine. And this machine costs how much? 800,000. Put it at this amount. Then obvious, after 5 years, you want to sell the machine. Obviously, the machine will depreciate, will lose value. Means it will lose, there's a minus. After 5 years, maybe at an interest of 7% per annum, just per annum only, not compounded quarterly or whatever. You do not divide by anything, they do not say anything. They just say 7% per annum. Obvious, what we're going to do, we can calculate, we can know that, okay, at the end of 5 years, if you want to sell your machine, at what amount are you going to sell your machine by? Obviously, you're not going to sell the machine by an amount that is bigger than what? By 800,000, because it is a scrap now, it has lost value. It has depreciated, so it means you're going to use the formula A equals to P into 1 minus I. You see now, I'm not using simple interest formula. What is the P? 800,000. The current machine cost 800,000. What is the interest? 7%. It's not, you don't divide by 12 or any, so it's 0.07 for 5 years. So what will be the amount at the end of 5 years? So we can determine that. 1 minus 0.07. Don't have a calculator, guys. To the exponent 5. Then we multiply that by 800,000. So this will give us 5 556 point, no, 556,550.70. So it's 556,550 rand and 70 cents. So this is the book value, is the value that you're going to sell the machine at the end of 5 years at that interest rate, at that depreciation rate. Obvious, at the end of 5 years, you're going to sell the machine. And where you're going to sell the machine, they're going to give you 556,550. You have this. You have this amount. You have this amount at the end of 5 years. But now you bought this machine for a business. Obvious, the production or whatever you're dealing with, you need to buy another machine so that your company keeps on running. So obvious, if you go to the same dealer where you bought your machine, due to inflation rate, the same machine you bought, maybe they will modify it now. You have to buy another machine, a new one. Obviously, the new machine will be more than the price that you bought with. So it's going to increase, going to appreciate. So what will be the value of the new machine? Obviously, you have to use the formula to say, okay, A equals to P into 1 plus. I'm using the plus 1. Let's say the interest rate, the inflation rate, let's say it's 10% per annum. Not compounded monthly, and no, we're not doing anything there. So what is the A, the P? The P is 800,000. The interest is 10%. 10 over 100. Obviously, 10 over 100 will give us 0.1. We're not dividing with 12 or anything because they did not say anything about that. So it's the power of 5. So now, you see, I did not use any simple interest. We use simple interest only when we are told to do so. And I apologize. All right, then now, so it's going to be plus 1 to the power 5. Then you multiply by 800,000. Want to know the value of the new machine that you're going to buy. I remember it will be, so it will be 1,288,408. So this is the price of the new machine. So you see that is the appreciated value, is this thing, this. So now look at this. We want to know what is your sinking fund. I want you guys to listen to me. Remember, you took your machine, 5 years has arrived, you sold your machine at this amount. Now you have this. I can say you have this in cash. What you're going to do, remember you need a new machine. So you're going to take this amount and you pay like as if it's a down payment or a deposit. So what are you going to be left with in order to replace this value of the machine? Obvious, you're going to take this value as 1,288,408. Then you subtract what you have right now, which is 556,550.70. Then the balance, it is your sinking because you do not have that amount. So it's going to be 556,550.70. So that balance will be your sinking fund, 731,857.30. So it means this sinking fund, you do not have this amount. What are you going to do with this? It's either you go to a bank and you take a loan, or you start making investment in advance in order to get the money, because you do not have it. So this is an amount that is needed to replace the value of your asset. Remember, the price of the new machine costs this, but you only have this. So you see that the balance, it is your sinking fund. This is how we determine it. That's why in the exam they will say, determine the book value. It means they want you to calculate this. And they say, what will be the cost of the new machine if the inflation rate is this? So all the time, if they talk about inflation rate, you have to use a plus formula, not a minus. Then what will be the sinking fund? These are exam typical questions, guys. Very important. Very, 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 very important. Okay? All right, now we have to move on. Remember, whatever I was talking about is for grade 11. So it means a learner who's in grade 11, whatever I was just talking about in finance, it's relevant for grade 11 learners. So even the grade 12, you have to know these things are very important. Remember, it's easy to get wrong formula. You have seen that I did not even use any simple interest formula. We use simple interest formula only when they say on a simple interest basis. Right, let's come to these guys. And there's something very important about this. 4.2, this for grade 12 only. Annuities. Guys, I don't want to teach more, but I've explained what, like under annuities, what do you mean by an annuities? An annuities is an equal payment, made at regular intervals. So if, let's say, you took a loan from the bank and you agreed with the bank that monthly or quarterly, or it depends, that you will be obliged to make equal payments, whether it's monthly or it's quarterly or whatever. So as long as you are making equal payments, then this is referred as an annuity. So how do you see that as an annuity? It's when there is an equal payment that is being made. So it means it's no longer compound, whatever. So this is just an annuity. But there are two types of annuity. We have what you call present value annuity and future value annuity. But the present value annuity, we only use present value annuity when someone has taken a loan or a mortgage bond. The future value annuity exists when we are dealing with investment or savings. And these are the formulas. They actually give you these formulas in the formula sheet. Let me write them down. And because, sometimes most of the learners, they get, their marks are reduced because of not understanding what they're doing. Remember, from the future, the annuity formula, there are two formulas. There's the first one, it says PV, it's X into 1 minus 1 plus I to the power minus n all over I. And we have FV equals to X into 1 minus 1 plus I to the power minus n all over I. Oh, so no, I apologize. So the future value one is, I'm too excited, 1 plus I to the power of n minus 1 all over I. And guys, you must be careful here. You only use these two formulas when there's an equal payment made. If there's not any equal payment that is being made, you're not going to use this. And by the way, you use this formula when they're talking about loans. And guys, I'm not saying wherever you read, when you see the word loan, it means you must start using the formula. No, it can be a loan, but just on a compound interest. I'm referring to a case where there's an equal payment that is being made and it's a loan, then you use this. But if you're just talking about investment or savings, then you have to use the future value. Only when there's an equal payment made. And what is the X? The X is not the monthly payment, just an equal payment made. The I is the interest rate, the N is the number of payments, This is there in the formula sheet. And remember, guys, we only use these two formulas when the payment that is made here, it's not starting immediately. It's not immediate. So it means someone opened an account here. Maybe at the end of the month, they start making payments. You see that this is not starting, it's a 1 month time or one, so you understand. So if the payment was made, but it was not like the person did not even open an account, but did not save money immediately. So you have to use this formula. But it depends, because it can make money immediately, but the last payment was not made at the end of the period term. So it means it's still not an immediate payment because it's not made up until here. And there is one of the misconceptions that, but this actually, I want to be honest with you, is done by us. Especially when we're dealing with immediate payments, they say you take the formula for the present value, like if it's immediate payment, whether it's you increase the end by 1, it's wrong. I want to say it now because I'm 100% sure of what I'm telling you. If you go and take any financial calculator, you try to work it out when the n is added by 1, you'll see that you are just estimating. It's not the correct value. But I will explain this. This is very, 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 very important, guys. Yes, it's an estimation, but it's not in actual fact. It's not. Even if you can go and look at the financial mathematics, whether those people who are doing actuarial science, they will tell you that you cannot adjust that by n plus 1. But I don't want to make this a debate. I'm talking about a reality. So now look at this. Look at this. If we are talking about this, then now, okay, let me talk about this. There's some cases where you find that like there is a payment that is being made here. I want to address it. Let's say one opens an account now at time 0. Although it's not going to be possible with a loan because it's not possible to be given money now. And at the same time, you start making payments. They give you a loan now and you start making payments now. Usually we have something, it is called starting immediate payments. Starting immediately. All right. In terms of the starting immediately, guys, we have this case. I want to explain to you so that you can understand why we do not have to make adjustments. Remember, if we have a timeline, if there is a timeline here, let's draw a timeline. Right, in case of future value, I want to talk about, because this starting little actually applies when you are dealing with future values. You open an account now, and suddenly you make investment now. And then now, look at this. Second, it's X. Third, it's X. X up until, let's say here up until you still make X. No, it will not be starting immediately if you do not, you just make here, not at the end. Okay, fine. Let's say it's XX throughout. So which means that this amount here, if it's not an annuity, it will just accumulate up until the end period. So this will be X adjusted for 1 plus I to the power of n. Plus, we will come to this. This will be X adjusted for 1 plus I to the power of n minus 1. Same applies. So it means you're going to end up having X adjusted for 1 plus I squared plus the last one. Okay. So the last one will just be X adjusted for 1 plus I. So if we reverse this, remember we want the future value. If we reverse this, this would be X into okay, let me just write this nicely. So now this would be, if we were to write this, it will be, the first one will be X into 1 plus I, X into 1 plus I squared, X into 1 plus I cubic, and so on up until this one. So which means now this will be my, remember we are using geometric series here. So the sum of n will be a into r to the power of n minus 1 over r minus 1. So look at this. The first term now will be, it is the 8, x into 1 plus I. We're making adjustment. So what is the interest there? It's going to be 1 plus I to the power of n minus 1. This other one will be 1 plus I minus 1. So we end up, we're going to call this a future value. So this will be x into 1 plus I to the power 1 plus I to the power of n minus 1 divided by I. Now, in most of the cases, in most of the cases, they say, once you read the question, then they say starting immediately, but it end at the, so you just take the formula here, the future value here, you just adjust this n only, where you adjust this n only by 1. Once you make this adjustment by 1, that will accommodate those total number of payments that will be made. Now, the problem is 1. Let's look at this. Since there's an interest added there, let's multiply this inside. You see that if you're doing that, it means if you're adjusting by 1, even the 1, this one should also be affected. Now, look at this. This becomes future value. It's x into 1 plus I into, oh, okay, no, I wanted to multiply in. These are just some of the misconceptions. Like then now, let's multiply. If you multiply in, this will be 1 plus I. Yes, it will be n plus 1. Now the problem is 1. We have to also affect with this. Remember, we have to multiply this on 1. So you see that we're going to have 1 plus I now. So divide by I. So you see that once we have made an adjustment here, how about this one here? So that's why when you are given a starting immediately payment, your adjustment should be on x. You adjust the x with 1 plus I, not adding the n plus 1, because if you're adding the n plus 1, it means that you need to also affect the other payments that side. But there's a trick behind this, because it can be starting immediately, but you find that the last payment was not made at the end of the maturity period. Then already the payments are affected. But now I will do an example. Which will actually cover this. I will do an example which will cover this, to say we do not add by 1 year, because it was starting immediately. Maybe he paid like from 1 up until 20. You just say 20, you add by 1, you're gonna have 21 payments. Yes, 21 payments, but how about the interest incurred? That's why if you can take any financial calculator, you confirm this, what I'm telling you, you will find that the answers, it is true when we are using this. Not when you are making adjustment on the n plus 1. So it's very important. I'm not trying to create a debate, but I'm trying to actually show what is actually true when you're dealing with starting immediate payments. Let me do one example to explain what I'm actually talking about. Remember, we make adjustment when they say starting with, but must be careful. You can be starting immediately, but you find that the last payment is not made at the end of the maturity period. So it still is not an starting with, because the payments will still be the same as when we're using that other one. So now, which means, what can I do? Should I maybe pause this one and look on the, okay, let's just, I don't have to require me to have the financial calculator, but it's fine. Let's do this. Let's say in terms of a timeline, let's just make a timeline. We make two comparisons. Let's say someone opened an account and immediately from the start, he deposited 1,200. 1,200. Let's say up until, let's say he made roughly 20 payments, 20. The last payment was maybe at the end of month of 20. Okay, so this 1,200. Then we are told that, okay, fine, the interest was, let's say it's 7%, just an example, per annum, let's say compounded monthly. Okay, let's assume this already, it is in months. So now already you see that the payment was made at the start and at the last payment, at the end. So it was just made. So I want to know what is the future value. Let's do this. With the same, remember the equal payment which was made, that's why it's X is the 1,200. The interest is 7%, so it's 0.07 compounded quarterly. Right, already this is the number of years, is the payments, they are in month already, we just write 20. It's just an example. So already, if I were to use, let's say we know this is, we want the future value because this is starting immediately because it was made here, starting immediately, and it ended at the end of the maturity period. So now, which means what we're gonna do, we're gonna say, okay, right, since this is the information that we have, okay, just a minute, guys. Guys, I apologize. So now the formula would be, I want to start with this one. Let's say it's X into 1 plus I into 1 plus I to the n minus 1 all over I. What is the X? The X is 1,200. The rest is 0.07 over 12 into 1 plus, what is the interest? 0.07 over 12 to the power 20, not 21, minus 1 because I've made an adjustment that side. So this is 0.07 over 12. So I want us to compare this answer. This is the first option. 1. Let's now move on to option 2. Option 2 is that one where, like an intuition there, like where they say, since it's starting immediately, we just add the n plus 1 here, minus 1 over I. Okay? Let's do this. What is the X? 1,200. The interest is 0.07 over 12. Payments 20 plus 1 is 21, minus 1 over 0.07 over 12. I want us to get these two answers. Unfortunately, I don't have a calculator, but I'll try my level best to explain it thoroughly. So, okay, let's work this out. So I'll just say, we'll just try to be fast here. 0.07 divided by 12 plus 1 to the power of 20, then minus 1, multiplied by 1,200, okay, times by, let me just say, open bracket 1 plus 0.07 divided by 12-ish. Let me just put it in brackets because I don't want to, okay, like, right. Then now, with this, let's divide by 0.07 divided by 12, if I'm not mistaken. Okay, this one will give us a value of 225.76. Okay, let's work out this side. Then now, this side, you're gonna have 0.07 divided by 12 plus 1 to the power of 21, yes, minus 1 multiplied by 1,200. Then we divide by 0.07 divided by 12. So this is giving us 26,725 rand and 76 cents. This is just an estimation, but the amount are a bit different. Now, I wanted us to do this. The X is 1,200. The interest is 7% compounded. And this is 20 months. It's already multiplied by 12. So it's 20 divided by 12, 20 divided by 12, which is 1.7, roughly there. So I want to do this, guys. Let me do this because I want to write this amount. Okay, let me close here. I want to write this amount so that you can easily see, okay? Let me say option, what is this? Option 1. Option 1. What is the future value for the first option? Is 26,725.76. The option 2. Option 2 is 25,525.76. This one is for the one where I said we need to make adjustment with 1 plus I only on the future value. Right. Then now, I want us to do this. I want us to use any financial calculator to confirm the answer. Right. What I'll do is, okay, let's just go and search for any financial calculator. There. Okay, guys, I wanted to address that part where I wanted to confirm using a financial calculator. From the amount that we calculated for the first option, option 1, the amount was, is it option 2? It's not option 1. Option 2 is the amount, it's 26,725 rand and 76. So this one is that one we just add by n plus 1. So then the option 1 is that one I said we adjusted with the interest. Then this is 25,000. Let me confirm the answer. 25,525 rand and 76. So we said the interest is 7% annum. Then the monthly payment is 1,200 for 20 months. But we want to ensure that it is starting immediately. So now compounded monthly means 12. So let's now go to financial, like let's use the financial calculator. So I'll just say Texas financial calculator online. Which one can we use? Okay, let me try this. I want to confirm between these two amounts, which one is the correct answer in terms of what I just said. Okay, so here's our financial calculator. We want to compare between this amount and this one. Right, now let's do this. What is our N? In terms of this, let's try to clear here. I will clear this one. Then, oh, sorry, we need to come up with the setting. The setting, what do we want? We want to, or beginning, want our payments to start immediately. So we're gonna click at the beginning, then we enter, so it's 20, Interest per year, it's 7%. Present value, this is a future value annuity. So I'll just write 0.00. What is the PMT? PMT, it's how much are we paying monthly? So I'll just write 1,200. Then payment per periods per year, interest. The interest, let me just put 12 here. Let's check what is the amount. Let's check the amount, calculate. Then it says present value need to be numeric. Okay, so it means I have to put this one. So it's 12. The interest is not going to change. Yes, it's now giving us 25,000. This 12, it's like we're dividing the interest by 12 and we multiply the number of years. Already, this the period is 12, but it's now calculating it in years, then it multiplies. It knows that this is in months. We've already computed it. So you see that is giving us 25,525 rand and 76. So which one? It's like from the financial calculator, it is attesting to the formula that I've used, that if you are having starting immediately payments, the formula to use is the one where we adjust by 1 plus I, not just by adding on n plus 1 only, because if you are doing that, it means this one must also be affected. So this is this one. But now let's also use another formula. Let's also use another financial calculator. So let's go back and try another financial calculator. I wanted to use an option where we use maybe Texas Instruments. Okay. Right. So, okay, let's move on to another financial calculator. Time value of money. All right, then we're going to look on another one. Okay, let me just say Texas financial calculator. TA plus, yeah, time value of money calculator. Let's use the time value of money calculator. So we wanted to actually confirm the two amounts, which one is the correct. So already we've seen the first one, it says this is the correct one. So later I wanted to use a different one. So you see that here, if we let this at the end, it means now it's not starting immediately. It means we do not have to make any adjustment. If we click at the end only, we put amounts for the end. So we are saying there's no starting immediately. It was just paid 1 month. So now we want it to be starting immediately. So it means what you do, we go and say this is a starting immediate payment. Present value is 00. How many the payments? What was it was paying 1,200. I'll just make a minus. We want the present value. What is the annual interest? The annual interest is 7%. What is the period? The period is 20. The period is 20. This compounded monthly. So let's make the present value. We want to compute present value. Yeah? You see, it says present value, it's 25,000. Okay, I apologize. It says the present value is 25,000, 525 rand and 76 cents, which means this is the amount that we computed. So it is that one. But if we were to confirm that if we do not use starting method, we just say x into 1 plus I to the power of n minus 1 over I. It means this one is 1,200 into 1 plus 0.07 over 12 to the power of 20 minus 1 over 0.07 over 12. This one is just an ordinary future value annuity without, like, we're not talking about starting immediately. So I want to confirm something. Let's work out using our calculator and confirm when I click there, where there's an end there. So this will be 0.07 divided by 12 plus 1 to the power of 20, then minus 1 times 1,200, Then let's divide by 0.07, divide by 12. Like what I'm doing here, I'm not doing starting immediately, I'm just doing ordinary payments. So this has to give us 25,377 rand and 73 cents. So let me click where there is a end means I don't want it to be starting immediately. So you look at the amount, look at this amount here. Look at this amount here. It will change because now it's not starting immediately. You see, it's now giving us 25,377 rand and 73 cents, which means making adjustments starting immediately does not need us to make adjustment on the end only. It must also affect it's actually have to affect even the one. So we need to be careful like in terms of calculation. So it means the correct one is to use the if you're making n+1, it means you also have to adjust the 1 year with the 1 plus I. Then the payment will be the same. So which means from now on, when we're having starting immediately payments, we make the adjustment on the X. Starting immediately payments, we make adjustment on the X. But we need to be able, we must be careful. We might have starting immediately, but you find that the last payment is not at the maturity period, it's before the maturity period. So it means in that case, this will not be a starting immediately, we'll just use an ordinary future value annuity, even if they say starting immediately. But if it starts from 0 and it end at the maturity, then that is actually starting immediately. So you need to understand, because let's say if it's 20, but the payment was made on period 19. You see that from period 19, the adjustment we'll just use 20 instead of that, but it's not a starting immediately. So you need to understand that. So I wanted to actually address, because I've done it in the video, but it was not visible. I don't know what happened. So I'm just adding it. I believe you are well. Okay, thank you, ladies and gentlemen. Right, what do you mean by an outstanding balance? Let's say you took a loan. Maybe you're supposed to pay a loan for, let's say, for 5 years, compounded monthly. 5 times 12 will be what? 60. So it means 60 payments. You're supposed to make 60 payments. But now, along the way, what happened? Let's say you paid a certain amount, an equal payment, 5 times 12, okay, 16. Then now, along the way, okay, let's say it was not starting immediately. You took a loan now. Already when you took a loan, you cannot have starting immediately. So maybe they can give in 1 month's time. So you start paying here. Maybe you made, let's say you paid for, let's say, for 2 years, 2 times 12. So it means you made 24 payments. 24 payments are already made. So number of payments made or already paid is 24. How many payments are you still owing? Or the remaining payments? So obviously it will be 60 minus 24. So this will give you 36. So now you need to be able to understand this. There are 2 formulas of calculating the outstanding balance. The first one, it says when you're calculating outstanding balance, you can take the accumulated amount, then you minus the future value. So this will be P into 1 plus I to the power of n minus X into 1 plus I to the power of n minus 1 all over I. Then the second one, it says to calculate the outstanding balance, you can just use the present value annuity. Obviously, with the present value annuity is just X into 1 minus 1 plus I to the power minus n over I. But you need to be careful here. You'll choose which one is the relevant formula, but there's one that I know that is one of the easiest, which is the second one. But you need to be careful. If you are using the first formula, The end that you're going to use here, it should be the number of payments already made. Number of payments already paid or already made. So you see this person was paying X amount and he made how many payments? 24. So if you are using this, you have to put 24 here. But if you're using this, you must use the number of payments still owing. So it means if you're using this one, you have to use 36. The answers would be the same. But usually, to be honest with you, this is the best formula. Because why? You know, when you're calculating outstanding balance, you just think of the present value annuity formula only. Within that, you just write the present value annuity. But the problem is you need to be careful with your end. If already this person had made 24 payment, means you will need to look on the other ones that are still owing to use it here. The answers will be the same. So this is a formula to tell us the amount that this person is still owing before maturity period. Do this, you can say total amount paid. You add with the outstanding balance, you minus the loan. Because inside the brackets, it's loan minus outstanding balance. How to do this? For example, let's say someone was paying a certain amount, let's say 1,200, maybe for 24 months. Already 1,200 for 25 months means the total paid amount will be how much? It will be 1,200 multiplied by 24. Plus loan amount, how much did he took the loan? Maybe he took around, let's say, he took a loan of, just an example, 50,000. So it means the loan amount will be 50,000. If you put 50,000 here, the outstanding balance, you have to calculate the outstanding balance to say if he had made 24 payments, how many payments are still owing? So we have to calculate that outstanding balance, then we must minus the loan. So this is the formula for calculating, but I will create a video for this one. Determining the number of payments using logs. So this is just about saying if you're given present value formula or future value formula, and you're given PV, you're given X, you're given I, what is the end? Always you have to use logs. Deferred payments, what is this, guys? A deferred payment actually disturbs the annuity because, for example, let's say one was paying a certain amount monthly. Maybe after 20 months, maybe at the end of 21, 22, he stopped, like he or she fails to make payments. Then he start making payments maybe after the 23rd month. So because of this is an example of a deferred because there was payments which were still were not paid. Because of that means one must be able to know, okay, fine. You have to calculate the outstanding balance to say what was the outstanding balance just before he made the last payment at the end of 20 months, so that we can be able to know how much this person still owing. Then the bank, what we do to say, okay, if within that outstanding balance, we have to adjust for those 2 months that this person did not pay. Then we continue, we create a new annuity. I think I will address this using a video. Then the last one is the issue of calculating the final payment. Usually the final payment is calculated by calculating the outstanding balance during the last month. Actually, we adjust it by only 1 month. Only 1 month. Then this is called a final payment. I think I will address this using a video. So don't worry about that. But this is one of the easiest, ladies and gentlemen. It is one of the easiest of them all. I will address them using a video. So which means that after this, we'll have to, it will, for part 2, it means I will go through, what is this? Differential calculus, probability, and what is this? Probability and fundamental counting principles, probability and fundamental counting principle. So if you want to get an A+, you need to make sure that you understand everything that I just said now. But I'll also go through a video one by one. Okay, fine. We'll go through this in part 2. In part 2. The part 2 will address this. This will be part 2 on how to get an A+ in paper 1 during final. So this is straightforward. Kept sketching all that I said. Kindly watch the video that I've created on optimization, but I'll also talk about this. Here we're going to talk about addition rule, complementary rule, mutually exclusive events, events that are independent, how to construct a Venn diagram. And so some of these things, for example, addition rule, complementary rule, and Venn diagram, I've addressed it in the probability video for grade 10. So you can go and visit it. Unfortunately, I do not talk about the tree diagrams and contingency table. We'll talk about them in part 2. Right, ladies and gentlemen, without wasting time, let's now stop here. Please don't forget to like, subscribe, and hit the bell button for future video notification. Thank you very much, ladies and gentlemen. Take care. Bye-bye.